Okay, hello friends, myself Vishal, and today we'll start with first of our triathlon webinar. So I'll just brief you what is this webinar all about. So we'll go through the entire chapter of numbers. Okay, first we'll go through lap 1, which will include your remainders. So we'll solve all kind of problem that we can possibly get on remainders. Then we move on to our lap 2. Lap 2 is basically on your factors and factorials. Okay, so we'll cover all the possible problems that we can get on factor and factorials. We'll start with a very basic problem and then eventually we'll move on to a difficult problems. And then in the lab 3 we start with LCM and HCF. Okay, we'll basically see all the problems which includes application of LCM and HCF. Okay, so without wasting any time, let's start with the first triathlon. Okay, so certain things that I want or what I expect from this triathlon is this. This triathlon will start from lap 1 and go till lap 3. Okay, so lap 1, as I told you, will include remainders, lap 2 will include factor and factorials, and lap 3 will include LCM and HCF. What is expected from you before you sit in this triathlon? Solving basic material. Yes, because we are going to solve difficult problems today. So I expect you to know a little bit of basics related to remainders, factors, factorials, or LCM, HCF, which will help you to get the problem easily. Okay, so let's start with this. Yes, the first thing that will happen as we move through each of the lab. Okay, what will happen here? We'll first start with warm-up problems. Okay, so I'm expecting that a lot of you may not be having a knowledge related to numbers. So I'll start with few basic problems, which will give you a revision about factors or LCM, HCF or remainders. Then from warm-up problems, we move on to early checkpoints. Okay, early checkpoints will include easy problem related to a particular topic. From early checkpoints, we move on to hurdles. Okay, hurdles will include difficult problems in a particular lab related to a topic. And then from hurdles, we move on to peak points. Peak points will include very difficult problems which are included in the particular topic. Okay, so that is how we'll run through each of the lab. Okay, lab for remainders will start with warm-up problems, then moving on to early checkpoints, then moving on to hurdles, and then to peak points. Okay, so let's start with our first lab, which is on remainders. Okay, so what is it about remainder? So let me give you a basic idea. 8 divided by 7. Okay, what is a remainder in this case? You will say 1. Okay, 16 divided by 7. What is the remainder? 2. 24 divided by 7. What's the remainder? 3. But what do I do right now? I split them. I split this 16 as 8 plus 8. So 8 divided by 7. What's the remainder? 1, right? And again 8 divided by 7. What's the remainder? 1. Add this 1 plus 1, you get 2, which is the same remainder as this. Okay, similarly I can split up 24 as 8 plus 8 plus 8. 8 divided by 7, 1, 1, 1. 1 plus 1 plus 1. The remainder is what then? 3. So what is it like we understand about remainders? If the number is big, we split up the numbers. We get the individual remainders and then we perform the same operation on the individual remainder to get the final answer. Okay, so let's apply this to this as well. Now 8 divided by 7, we know that it's 1. 34 divided by 12. Okay, so what's the remainder? 12 2s are 24. What's the remainder here? 10, right? This is something we call as a positive remainder. So what kind of other remainder do we have? We have something called as a negative remainder as well. Now what is that? 8 divided by 7. Okay, so what do you do right now? You take the multiples of 7 and go beyond 8. Okay, so 7 1s are 7. I'm still not beyond 8. 7 2s are 14. Yes, whatever the number you get, you subtract from this number. So 8 minus 14 is nothing but minus 6, and that is now my negative remainder. Let's identify a negative remainder for 34 divided by 12 as well. Take the multiples of 12, go beyond 34. 12 3s are 36 and I subtract that number. 34 minus 36 is nothing but minus 2, and that is my negative remainder. Okay, still we are into the warm-up problems related to remainders. Okay, looking at the basic concepts of it. So I hope you understood. If the number is big, we split up the number, get the individual remainders and get the final answer. What is a positive remainder? We know. What is a negative remainder? We also know. Let's move on to the next. So I give you this problem now. 1956 into 1955 into 1954 divided by 19. Now how do I solve this? First way, I can multiply 1956 into 1955 into 1954. I'll get a 10-digit number. I can divide this by 19 and get the remainder, but that is tedious. So what do? I find out the individual remainder. 1956 divided by 19, the remainder is 18. 55 divided by 19, 17, since it is just 1 less than 56. Then 1954 divided by 19, the remainder is 16. Now the problem is reduced to 18 into 17 into 16 divided by 19. Now this looks easy, right? I can just multiply the three numbers, divide by 19 and get the answer. But negative remainders make me solve this problem easily. Now I find the negative remainder for 18 divided by 19, which is minus 1, right? As explained in the earlier concept. 17 divided by 19 minus 2. 16 divided by 19, the negative remainder is minus 3. Let's multiply. Minus 3 into minus 2 plus 6 into minus 1 minus 6. So minus 6 divided by 19. Okay. So this gives me the answer as what? 13. First thing that you have to remember about negative remainder, it is never an answer. Negative remainder is never an answer. It is just a concept to solve the problem quickly. Eventually, my final answer will always be a positive remainder. And how do I get a positive remainder from a negative remainder? Just add the numerator and denominator. Minus 6 plus 19 will be equal to what? 13, and that is my answer. Okay, so we applied the concept. If you don't know the answer for a big number, you split up the number. You find the individual remainders and then you get the final answer for it. So let's apply this to this. 2 raised to 40 divided by 3. Now what is the meaning of this? This is nothing but 2 which is being multiplied 40 times. Same thing I had written it here. Divided by 3. 2 divided by 3. What's a negative remainder? Minus 1. Again 2 divided by 3. What's a negative remainder? Minus 1. Again 2 divided by 3. What's a negative remainder? Minus 1. This minus 1 is now multiplied 40 times. So minus 1 multiplied 40 times is what? Plus 1. Right? Plus 1 divided by 3. So what's the remainder for this? 1. Whenever you see a number in the numerator which is lesser than the denominator, obviously that will be the remainder. So 2 divided by 3, again the remainder would be 2. Okay. So the answer in this case is 1. What if I make a 41 instead of 40? Then what will happen? Similarly, I'll have minus 1, but now the minus 1 is multiplied 41 times. Minus 1 multiplied 41 times or odd number of times will give me minus 1. Minus 1 divided by 3. But as we have learned, negative remainder can never be an answer. It's just a concept to solve the problem quickly. So to get the positive remainder, I'll add minus 1 plus 3, which is nothing but 2. And that is my final answer here. Let's move on to the next. Now I get 16 raised to 70 divided by 7. What's the remainder for this? Again, it's a big number, 16 raised to 70. So what do? I split up. I split it up into individual number as 16, 16, 16, which is multiplied 17 times. Now 16 divided by 7, remainder is 2. Again 16 divided by 7, remainder is 2. How many 2 I'll get if I go on this way? 270 times. 270 times is nothing but 2 raised to 70 divided by 7. Now there is a trick here. Now even if I further split this number, I am going to get the same number. Now comes the rule number 2 in remainders. After you split up, adjust the power. Adjust the power in such a way to get a positive remainder of 1 or a negative remainder of minus 1. Okay, so I need to adjust the power to get a 1 or a minus 1. So what will I write? I'll write 2 as 2 cube. You know why? Because 2 cube is 8 and 8 divided by 7 is 1. And that is what I want. Okay, so I write this as 2 to the power 3 to the power 23. 23 into 3 is what? 69. Okay, so I'm left with 1, 2, which will be here. Divided by what? 7. So I come to this now. So this turns out to be 8 divided by 7. Okay, but 8 divided by 7, remainder is 1. 1 multiplied 23 times. 1 multiplied 23 times is nothing but again 1 into 2, which is there at this side. So 1 into 2 is nothing but 2. 2 divided by 7. As the number is lesser than 7, that is my answer. Okay, so what did I do right now? I splitted the number. I got the answer. But then I saw I need to adjust the power. I need to adjust the power to get a remainder of 1 or a minus 1. So I wrote my 2 as 2 cube so that I can get 1 and I can solve the problem easily. Let's move on to one more problem in a similar way. 9 raised to 81 divided by 7. Okay, so how will I write this now? 9, which is multiplied how many times? 81 times. Okay, divided by 7. 9 divided by 7, what's the remainder? 2. Now 2, how many 2 I will have here? 2 multiplied 81 times. Okay, 2 multiplied 81 times. So I write it as 2 raised to 81 divided by 7. Now I cannot further split this up because after splitting only I got this as an answer. Now what will I do? Adjust the power. I adjust the power as what now? 2 cube. Why? Because again it will form an 8. 8 divided by 7 will be again what? 1. So I write it as 2 raised to 3 raised to what? 27. 2 raised to 3 raised to 27. Okay, so 2 raised to 3 is nothing but 8. So I get it as 8 raised to 27 now. 8 divided by 7, remainder is 1. 1 multiplied 27 times will again give me 1. 1 divided by 7. My answer is what? 1, since it is lesser than 7. Okay. So this is the two step of remainder. First, split up the remainder, try and get the answer. After that, adjust the power to get a positive remainder of 1 or a negative remainder of minus 1. Let's move on to the next rule of remainder, okay, which is called as cancellation rule of remainders. Now, what is that? 6 divided by 4, what's the remainder? 2. But you know what, I try to cancel this. 2 3s are 6 and 2 2s are 4. Then the number that is left is 3 by 2. Now 3 divided by 2, what's the remainder? 3 divided by 2, the remainder would be 1. If you can see, if I cut the number, the remainder changes. Initially the remainder was 2, now the remainder is 1. Okay, so you don't need to cut and get the remainders. But what if the problem is in such a way that you have to cut and get the answer? So cut it, get the final answer, but in the end, by whatever you have cut, you have to multiply the final answer by the same. So I had cut it by 2, right? At the start, I had cut it by 2. So I multiply my final answer 1 by 2. 1 into 2 is what? Again the same answer, 2. So what did we learn from here? You can find out the individual remainders, but if you try and cut, the answer will change. If I need the original answer from the changed answer, I need to multiply the changed answer by what I had cut. Okay, so I got the answer as 1, I multiplied it by 2 to get the answer of 2. Now let's apply what we have learned. So I come on to this problem now. 3 raised to 85 divided by 6. What do I do first? I split it up. Okay, that's what I know. 3 into 3 into 3, 85 times. Okay, 3 divided by 6, 3 divided by 6, and it goes on. But if you can see, even if I adjust the power right now, I cannot get a positive remainder of 1 or a negative remainder of minus 1. So what do I do right now? I cut this 3. So what is left now? 3 raised to 84. 3 raised to 84 divided by what? 2. Now remember, you have cut the remainder. Okay, you have cut the remainder. So the final answer will change. Whatever is the final answer that I'll get, I'll have to multiply it by 3 from the rule that we have just learned. Now the problem is easy. Now see, it's 3 divided by 2. 3 divided by 2, remainder is 1. 1 multiplied 84 times is nothing but 1. Okay, so we have 1 divided by 2. 1 divided by 2, the answer is what then? 1. Okay, but is it my final answer? No, I had cut it by what? 3, right? So I'll multiply this by 3 in the end. So my final answer for this is nothing but 3. Can I get the answer as 3? Yes, because my denominator is 6. I can get the answer as 1, 2, 3, 4 or 5. Okay, remainder will obviously be lesser than my denominator. Okay, so my answer here is 3. Let's take one more problem. 2 raised to 70 divided by 96. Now even if I split this up, I'm not going to get the answer. Even if I try and adjust the power, okay, I'm not going to get the answer. So what do I do right now? I cut it. Okay, I write it as 2 raised to 5, 32 into 3. Now I cut 2 raised to 5, 2 raised to 5. So what is left in the numerator? 2 raised to 65 divided by 3. Yes, does it click to you right now? 2 divided by 3, I am getting minus 1 as negative remainder, right? 2 divided by 3, which we have just learned. Minus 1 multiplied 65 times is nothing but minus 1. So I get the answer as minus 1 by 3. But negative remainder is just an concept to solve the problem quickly. Okay, it is never my final answer. So to get the final answer, I add them. Minus 1 plus 3 is nothing but 2. Is it my final answer? No, because I had cut by 32 at the start. Okay, so I'll multiply by 32 in the end. So 2 into 32 gives me what? 64, and that is my final answer to this question. Okay, so first rule of remainder, split. Second rule of remainder, try and adjust the power. Third rule of remainder, try and cut and get the answer. Okay, so if you want, you can write these 3 rules related to remainders. Let's go to next. Okay, next we come to something called as format theorem. Okay, and when will it click to me that I will have to apply a format theorem? The biggest hint here is your denominator will always be a prime number. So what will I get here? I will get 2 numbers, A and second number will be P, such that A and P are co-prime to each other. Okay, A and P are always co-prime to each other. What do you mean by this? Their HCF, highest common factor, is 1. Let me give you an example. 3 and 17. Okay, what are the factors of 3? 1 and then 3. What are the factors of 17? 1 and then 17. What's their highest common factor? 1. Okay, so A and P has to be 2 number which has HCF of 1. Okay, or else it will become a multiple of that, right? So the remainder will be 0. So that's why they need to be co-prime. And at the top, A raised to I need to have P minus 1. I need to have a number which is 1 less than my prime number. Okay, then the remainder for this entire thing turns out to be 1. Okay, let me give an example. 2 raised 2 divided by 83. So I know 2 and 83 are co-prime to each other. This is my A, this is my P, and I need at the top of this a number which is 1 less than the prime number. So 83 minus 1 is nothing but 82, right? So 2 divided by 83 raised to 82. So the remainder for this will be what? 1. Okay, this is what my Fermat theorem states. So let us solve few problems related to this now. I have 2 raised to 85 divided by 83. So 83 is a prime number. So I am happy that I can apply my Fermat theorem right now. So if 83 is at the denominator, I need numerator of what? 82. So I write this 2 raised to 82. But since this is 85, I'll get 2 cube. Okay, which will remain here. But according to Fermat, I know what? This is the remainder for entire this thing is what? 1. Right, so this turns out to be 1. Now what am I left with? 1 into 2 cube. 2 cube is 8. 8 divided by 83. Since it is less than 83, my remainder for this is what? 8. So that's how I can apply Fermat theorem. Let's see one more application of this. 2 raised to 106 divided by 53. Since I have 53 in the denominator, which is my prime number, I can apply Fermat. Since it's 53 in the numerator, what do I need? 52. So I split this up. 2 raised to 52. 2 raised to 52. This is 52 plus 52, 104. What am I left with? 2 square. Okay, now what will happen? 2 raised to 52 divided by 53. According to Fermat, the remainder for this is 1. Again, according to Fermat, the remainder for this is 1. 1 into 2 square. 2 square is what? 4. 4 divided by 53. My answer for this is 4. Okay, let's apply Fermat to one more problem. 26 raised to 57 divided by 29. Since 29 is my prime number, again I can apply Fermat. Since 29 is at the denominator, I'll need at the numerator, which is 28. 1 less than 29. So I write this as 26 raised to 28, 26 raised to 28, and then 126 will be left. Why? Because this is 57. 28 plus 26, 56, and this is 1. According to Fermat, the remainder for this is 1. According to Fermat, the remainder for this is 1. 1 into 26, 26 by 29. Since it is lesser than 29, my answer for this is 26. Okay, so that's how you can apply Fermat. So just remember the rules for remainders. As I told you, you can write this as well. Try and split up the remainder, adjust the power, try and cut the remainders, and the fourth rule is then if you see a prime number in the denominator, try and apply Fermat theorem here. Okay, so that's it about this part of remainder. Let's move on to the next. Now we have something called as Chinese remainder theorem. Now what is that now? N is my number divided by x into y. So for the first time I try and split up my denominator into two numbers, x into y, okay, such that x and y are co-prime to each other. This is again one thing we have to remember. Okay, x and y has to be co-prime to each other. What is co-prime? We have already learned the highest common factor for them is 1. When n is divided by x, which means when n is divided by this is, the remainder which we get is AC. When n is divided by y, we get a remainder which is say b. Okay, then what is the remainder for the entire expression? This is nothing but the smallest number which when divided by x gives the remainder of a, and by divided by y gives the remainder of b. Okay, looks quite theoretical. Okay, so let's apply this in a problem. So my n in this case, if you can see, is 128 raised to 100 divided by 53. So this is my n and this is my x into y, but I need to split this into x into y, right? So how will I write 53 in the factors of 2 such that it will always, x and y will be always a co-prime to each other. So I write it as 128 raised to 100, 17 into 9. Now what will I do? I'll solve it individually. 128 raised to 100 divided by 17, I'll find first remainder of this. Then 128 raised to 100 divided by 9. Okay, I'll find the remainder for this as well. Okay, so first time we are splitting up the denominator and trying and find the answer. So let's start with the first part, which is my 128 raised to 100 divided by 17. So I take it here. Now what will I do? As soon as you see 17, something clicks to you. Fermat. Okay, denominator we have a prime number. So I can apply the Fermat. So in the numerator, what do I need? 16. So I split it up. I split it up 100 as 128 raised to 16. But 16 raised to what? 6. Because 16 into 6 will be what? 96. Why am I doing this? Because it is 128 raised to 100. Why am I writing a 16 here? Because I want to apply Fermat. There is a denominator, I have a 17. That's why I split it up in this way. But after splitting up in this way, what am I left with? I am left with 128 raised to 4 here. Okay, but according to Fermat, if we know, the remainder for this entire thing will be what? 1. 1 raised to 6 is what I am left with after this. 128 raised to 4 will remain at this side divided by 17. Now will I solve this? 128 raised to 4 divided by 17 is what I have right now. Now divide 128 by 17. What's the remainder that you will get? 9. Okay, so it is nothing but 9 raised to 4. Now again I write 9 raised to 4 as 81 into 81 divided by 17. Now what do? I apply the concept of negative remainder. 81 divided by 17. 17 5s are 85. As I told you, what is negative remainder? Take the multiple of 17, go beyond 81. 17 5s are 85. I subtract 85 from this. What do I get? Negative remainder as minus 4. Again here minus 4. Minus 4 into minus 4 will give me plus 16. 16 divided by 17. Since the number is lesser than 17, my answer is 16. So what did I find right now? 128 raised to 100 divided by 17. The remainder for this is 16. Now I need to go to the next part. What is next part? 128 raised to 100 divided by 9. So let's come to this. 128 raised to 100 divided by 9. So if you divide 128 by 9, the remainder will be 2. How many 2's are you getting it here? 100, right? So I'll write it as 2 raised to 100 divided by 9. Now what do I need right now? I need one number to adjust the power to get a positive or a negative remainder of minus 1. So I adjust the power. I adjust the power as 2 raised to 3 raised to 33. Now you will ask me, why am I doing this? Because 9 is not a prime number. I cannot apply format. So I need to go ahead with now writing it and adjusting the power of it. Okay, so adjusting the power of it. So I adjusted the power by writing 2 raised to 3. Why? Because 8 divided by 9 is minus 1. As you remember rule number 2, we need to adjust the power to get a 1 or a minus 1. I cannot get a 10 from 2, so I got 8. So I wrote it in this way, into 2, one isolated 2 which will remain here. Now I write the same thing as what now? 2 raised to 3 is nothing but 8. So I write this at 8 raised to 33 into 2 divided by 9. 8 divided by 9, what's the remainder? Negative remainder. If you know, it is minus 1. Minus 1 multiplied 33 times, odd number of times, will give me again what? Minus 1. So minus 1 raised to 33 into 2 divided by 9. So what am I left with? Minus 2 by 9. As we had learned it earlier, negative remainder is never the answer. It's a concept to solve the problem quickly. So to get the positive remainder, I add minus 2 plus 9 is nothing but 7. And that is my answer to the question. But is the problem solved? No. Okay, what do we need in the end? The smallest number. Yes, a smallest number which when I divide by 17, it gives me a remainder of 16. So this will be hello guys, sorry for all the trouble that you have got because of the heavy rains at Mumbai. Okay, the internet connection is not working as it should. So this should not stop us. Okay, so let's start. I think I had finished till Chinese remainder and hopefully everyone have understood what has happened till Chinese remainder. Just one. This will be recorded now, entire thing. Okay, so from the start till here, everyone who has missed till now, this will be recorded and this will be uploaded on our YouTube channel. So if you are thinking you have just joined right now, it missed the earlier part because I covered the basics in the earlier part. So you can just see the same video on the YouTube. Okay, it will be uploaded from the start. Okay, so not a worry. So let's start from Chinese remainder. As I told you, okay, I'll just repeat it because I don't know when the internet connection just went off. So I'll start up with this. I started with Chinese remainder. I said a number as 128 raised to 100 divided by 153. I just split the number into two parts, as I told you, 17 into 9, such that the two numbers has to be co-prime to each other. Then I found the remainder for 128 raised to 100 divided by 17. Okay, I applied a format theorem. Denominator was 17. I put it here as 16. 16 into 6, it is what? 96. 128 raised to 4 was left in the end. I found out the remainder for this, which was 1. 1 multiplied 6 times, 128 raised to 4 divided by 17. Okay. Eventually, I divided 128 by 17, 9 raised to 4. I split 9 raised to 4 as 81 into 81 divided by 17. Then I found out the negative remainder for 81 divided by 17, minus 4, which was 16. So 16 divided by 17, I got the remainder as 16. Okay. Hope you got this concept. Then I went on to the next number, which was 128 raised to 100 divided by 9. Okay. So I came here with that. 128 raised to 100 divided by 9. Since 9 was not a prime number, I didn't apply format here. I went to rule number 2, adjusting the power. Okay, so I wrote 2 as 2 cube to get a negative remainder of minus 1. Okay, then I wrote it as 2 raised to 3 raised to 33. 33 into 3, 99 into 2 was left in the end. So this was left at 2 raised to 3 is 8. 8 raised to 33 divided by 9 into 2. 8 divided by 9, I found out the negative remainder as minus 1. Minus 1 multiplied 33 times is nothing but minus 1. Minus 1 into 2 is minus 2 by 9. But as you have learned earlier, negative remainder is never the answer. It's a concept to solve the problem quickly. So I got the positive remainder by adding them. Minus 2 plus 9 is nothing but 7. Okay, but this is not my final answer. As I told you, we want the smallest number of this form. When I divide that number by 17, I get the remainder as 16, which is of this form then. 17m plus 16. Put m as 0, the smallest number is 16. Put m as 1, the next number is 33, and then so on. But the same number, when I divide it by 9, I should get a remainder of 7. Okay, when I divide it by 9. So this is of the form now 9n plus 7. Put n as 0, smallest number 7. Put n as 1. The next number would be 9 plus 7, which is 16, and 16 is my answer. Okay, divide 16 by 17. What is the remainder? What is the remainder? 16. Divide 16 by 9 as well. Divide 16 by 9. So you get the remainder as what? 7, right? And this is what I wanted. A smallest number which when divided by 17 gives me a remainder of 16, which is 16 itself. And the same number 16 when divided by 9 gives me a remainder of 7. Okay, so that gives me the final answer by using Chinese remainder. So hope you remember the flow right now. Okay, splitting up, adjusting the power, cutting it, applying the format theorem, and then eventually moving on to the Chinese remainder. Okay, and what is the speciality about Chinese remainder? We split up the denominator and we get the two numbers as co-prime, and then we eventually solve it. Okay, so remember the basics related to each of the problem. After the Chinese remainder, we move on to our Wilson's theorem. Now, what is Wilson's theorem? As it is being stated, when p minus 1 factorial is divided by p, the remainder is p minus 1. What does this state? So 28 factorial is divided by p, which is my prime number. Yes, 29 is my prime number. Okay, divided by this will give me a remainder which is p. Now, what is p in this case? My 28. Okay, so this is what it says. When p minus 1 factorial is divided by p, where p is a prime number, the remainder for this will be what? My p minus 1. Okay, so 28 factorial divided by 29, the remainder is 28. Just remember this, that's a direct answer once you get problem related to Wilson's theorem. After the Wilson's theorem, we move on to certain properties related to remainders. Okay, I hope that you may be having many doubts related to remainders. So as soon as we complete lap 1, okay, you can throw your doubts to me related to remainders, and after that we'll move on to our lap 2, which is factor and factorials. So let us now see few properties of remainder. First property is this: a raised to n plus b raised to n is divisible by a plus b when n is odd. Now what is this? Let's come to this. Let's take an example. Okay, 17 raised to 21 plus 10 raised to 21 is always divisible by a plus b. What is that? 17 plus 10, 27. If n is odd, is n odd? Yes, n is 21. Okay, so if this is divisible, the remainder for this, if I give you this, 17 raised to 21 plus 10 raised to 21 divided by 17 plus 10, which is 21, the remainder for this will be what? 0. Because this is completely divisible by this. The condition is n has to be odd. N is odd here. Okay, so first property of remainder. Second, a raised to n minus b raised to n is divisible by a plus b if n is even. Now let's come to this. 17 raised to 22 minus 10 raised to 22 is divisible by 10 plus 17, which is nothing but 27. Okay, given that n is even, yes, n is even, it is 22. So remainder for this will be what? Again 0. Okay, because it is divisible by this. Next, and the last property on remainder we'll see is this: a raised to n minus b raised to n is divisible by a minus b irrespective of n. Okay, so whether my n is odd or it is even, it is always be divisible by a minus b. So let's see this. 17 raised to 21 minus 10 raised to 21 will be divisible by a minus b. 17 minus 10, 7, irrespective of n. Okay, even if n was even or it is odd, it will always be divisible. So remainder for this will be 0. So just remember few properties related to remainder as well. You can get the direct questions on this. Okay, so if you know the property, you will get the answer in minutes. After this, let's move on to one application of this. Okay, so this is what a raised to n plus b raised to n divided by a plus b. Okay, 2 plus 5, which is 7. The remainder for this will be what now? 0. Okay, as we have just learned the property, a raised to n plus b raised to n is divisible by a plus b. Yes, a raised to n. If n is odd, n is odd here. N is odd here. Okay, so a raised to n plus b raised to n will be 5, 5, 5, 5 plus 2, 2, 2, 2, 7, 7, 7, 7, which is nothing, will also be divisible by 7 here. Okay, so the remainder for this will be 0. Now let's practice certain problems before we move on to hurdles and peak points and remainders. So I give you first problem, 2 raised to 1857 divided by 51. Now I see 51 as what? I can write this as 17 into 3, apply Chinese remainder and get the answer. But I am looking at some other way. I cannot apply Fermat theorem here, right? Because 51 is not a prime number. So what will I do? I know one more way, adjusting the power. Okay, which we have just learned. So let's see, how can I adjust the power to get a positive remainder of 1 or a negative remainder of minus 1? I write this as 2 raised to 8. Okay, what is 2 raised to 8? 2 raised to 8 is 256, right? 256 divided by 51, what's the remainder? 51 5s are 255. Okay, so the remainder here is 1. That's it. That is what I want. I want the power of 2 to be 8 so that I can get a positive remainder of 1 here. Okay, I am applying rule number 3rd here. So what will happen? I will get the remainder of 1 here. Okay, so this is happening. But what will I write? I will divide this by 8. I divide this by 8. I get the quotient as 232. So 232 into 8 is 1856 and 1 2 will be left here. 2 raised to 1. 1 isolated 2 will be left here. Now the remainder for this is 1. So 1 will come here. So this is how 2 raised to 256 divided by raised to 232 into 2 divided by 51. 256 divided by 51, we know that the remainder is 1. 1 multiplied 232 times is nothing but 1. 1 into 2 will be what? 2. And 2 divided by 51. My final answer for this is 2. Okay. So I was not able to apply Fermat. I could have applied Chinese remainder, but I finally went on to adjusting the power so as to get a positive remainder of 1. So this would be my approach to this problem. Next, I get 2 raised to 53 divided by 7. Okay, I am happy here. Why? Because I see denominator as a prime number. First thing that comes into my mind right now is a Fermat. So I write 2 raised to 6 because I want a number which is 1 less than the prime number. Remainder for this is 1. 1 multiplied 8 times is 1 into 32 will be 32 divided by 7. How is this 32 left here? 6 8s are 48, right? I just divide this by 6. 6 8s are 48. So I get here as 8. 8 into 6 is 48. I am left with 5 here. That's why 32. That's why 32 here. Okay, so 1 into 32 divided by 7. 7 4s are 28. My answer is 4. Okay, so let's move on to next as well. 19. I see here 2 raised to 79 divided by 19. As soon as I see a prime number, I want 18 here. So I write it here as 18. 18 4s are 72. Okay, what am I left with? 7. So this 2 raised to 7 will remain here isolated. According to Fermat, remainder for this is 1. 1 multiplied 4 times, which will give me 1 into 2 raised to 7. 2 raised to 7 just comes here. So it comes here as well. 1 into 128 is 128 divided by 19. The final answer is 14. Okay, I'm just applying Chinese remainder, my Fermat theorem here. Let's move on to again, this looks like very easy problem, 11, so I need a 10 at the top. 10 into 6 is 60, 1 remains here. Okay, this complete thing gives me a remainder of 1. This gives me a remainder of 1. 1 multiplied 6 times is again 1. 1 into 2 is 2. 2 divided by 11, my answer is 2. Okay, just brushing up through all the concept so that you get the idea related to how to solve remainders easily. Similarly, I have 2 raised to 100 divided by 17. I'm happy it's a prime number. I need a 16 here. 16 into 6 are 96. I'm left with additional 2 raised to 4 here. According to Fermat, this is 1. 1 multiplied 6 times 1 into 16 is 16. 16 divided by 17, my answer is 16 here. Okay, so just a few brushing up through all the concepts that we have learned in remainder. So just remember, first we had splitting up, adjusting the power. Okay, then we had cutting off remainder. Then we had Fermat theorem. Then we saw Chinese remainder. Then we saw Wilson's theorem as well. And we also saw few properties related to remainders. Okay, after this, let's move on to solving this now. Okay, now this is an early checkpoint problem. till now we have done all brushing of our concepts. Let's start with one problem. 2 raised to 469 divided by plus 3 raised to 268 divided by 22. Now this would be a big number, so what will I do? I'll split up. I'll find the remainder for this. I'll find the remainder of this. I'll add the 2. Okay, so if the remainder for this is 6, the remainder for this is 5, I'll add the 2. 11 divided by 22, my final remainder would be 11. Okay, for the first thing I need to find the remainder of this. So let's put it here. I write it separately. Okay, that's my part 1. 2 raised to 469 divided by 22. What will I do now? It's not a prime number. I cannot apply format, but I try to cut. Okay, we had already learned this. If we cut, what will happen? So 1, 2, 1, 2 gets cancelled. What am I left with? This is 2 raised to 468 divided by 11 now. Now I'm happy. Why? Because I see a prime number at the denominator. 11 is a prime number. So I'll have a 10 at the top so that I can apply my format theorem here. So I had a 10 at the top. So 2 raised to 10 divided by 11. According to format, the remainder for this is 1. 46 will come at the top because I need to complete 468. So 46 into 10 is 460. What am I left with? Additional 2 raised to it. Okay, additional 2 raised to it which will come here. According to format, the answer for this is 1. 1 multiplied 46 times is nothing but 1 raised to 46. But this 2 raised to it, right? This 2 raised to it will remain here. So will remain here. So 2 raised to 8 is nothing but 256. 256 divided by 11, I'll get 11 2s are 22, 36, 11 3s are 33. So I'll get the remainder as 3. So this is my final answer? No. Do you remember that property when we cut the remainder? Okay, if you cut the remainder changes. Then what do you need to do in the end? Multiply by the number which we have cut at the start. I had cut by 2, so I'll multiply 3 by 2. So my final answer for this will be what? 6. My final answer for this will be 6. Okay, so I got the remainder for this. I got the remainder for my first part which was given to me as what? 6. Now I need to find out the remainder for the second part. Okay, so let's move on to here. Second part. This is my part 2, which is 3 raised to 268. Okay, let's come here. Yeah, which is 3 raised to 268 divided by 22. Okay, so I'll start with this again. What will I do here? Again, if I see a 22, I cannot apply format. I cannot even cut here because in the denominator I have what? 2 into 11. Okay, in the numerator I only have 3. How will I cut that? So what is the next step I'll go on to? I'll try and adjust the power. Okay, I'll write 3 as what? 3 raised to 5. Now what is 3 raised to 5? It is 243. 243 divided by 22. Let's solve this. 22 ones are 22. I'm left with 23. 22 ones are again 22. So what is the remainder here? 1. Okay, after adjusting the power, what is it like we look at always? We look at to get a positive remainder of 1 or a negative remainder of minus 1. So I wrote it as 3 raised to 5. But then I have to complete 268, right? So divide this by 5. 5 5s are 25. I'm left with 1. 8, 18, 5 3s are 15. So 53 into 5. What is the remainder? 3. 53 into 5 is 265. This 3 will come here because I need to complete my 268 divided by 22. Now I'll write this as 3 raised to 5 as 243. 243 raised to 53 then. Okay. Into 3 cube is what? 27 divided by 22. I already know the remainder for this is 1. 1 multiplied 53 times is nothing but 1. Into 27 is nothing but 27. 27 divided by 22, the answer is 5. So what is my final answer right now? What is my final answer? Let's come here. The remainder for this was 6. The remainder for this is 5. 6 plus 5 is nothing but 11. 11 divided by 22. My final answer for this is 11. Okay, so you know all the properties related to remainders. But now the only concern here is how will you apply those properties? Okay, so I'm not going to come in the exam and say that cut this. Okay, format, apply format. That is what is the practice will do for you. So practice as many problem on remainders and try and apply the property of cut, the property of format, Chinese remainder, Wilson's theorem. As many problems as you solve, you will get more practice on how to click with the problems on remainders. Now let's see one more early checkpoints. Okay, so from warm-up problems we have moved on to early checkpoints. The problem looks difficult now, right? 7 raised to 7 plus 7 raised to 77 plus 7 raised to 777 going like this end up to 7 raised to 1, 2, 3, 4, 5, 6, 7. 7 raised to 7 times. Now how will I solve this? As we have learned in the earlier part, if the numbers are bigger, what do? We find the individual remainder. So let's go for this. 7 raised to 7 divided by 8. What's the remainder for this? So I'll just find the first part of it. 7 raised to 7. Okay, this again I can write it as 7 which is multiplied 7 times divided by 8. 7 divided by 8. What's the remainder? Negative remainder, minus 1. The negative remainder for the next part, minus 1. Again for this part, minus 1. How many minus 1? Minus 1 multiplied 7 times. Okay, minus 1 multiplied 7 times is nothing but minus 1 raised to 7, which is nothing but minus 1 by 8. But as we have learned, negative remainder is never my answer. Okay, but I can get the positive remainder of 7 from here. But I prefer to keep it at minus 1. Okay, I prefer to keep it as minus 1. So I keep it as minus 1 because I'm not finding out the final answer from here. Now I go for the next part. 7 raised to 7 divided by 8. Okay, so what will happen here? Let's take the second part. 7 raised to 7. What do you mean by this? 7 is being multiplied how many times? 77 times. Okay, divided by 8. Again 7 divided by 8, negative remainder, minus 1, minus 1, minus 1. How many minus 1? 77 times. Minus 1 multiplied 77 times is again minus 1. Now can you identify a pattern here? Every time if it is 7 or a 77 or 777, you multiply minus 1 odd number of times. And whenever you multiply minus 1 odd number of times, you will always get the result as what? Minus 1. So how many minus 1 will I get in this way? How many minus 1? Check out how many 7s are there. 1, 2, 3, 4, 5, 6, 7. So I will get minus 1 7 times, right? So I will get minus 1 7 times. So minus 1, 7 times. Minus 1 7 times is nothing but minus 7 by 8. But as I had told you earlier, negative remainder is never the answer. Okay, so to get the positive remainder at minus 7 plus 8, 1. 1 is my answer to this question. Okay, so what did we learn from here? If the problem looks bigger, solve it in parts. Okay, take the one part, take the second part, take the third part. You will identify certain pattern. Okay, follow the pattern and get the final answer for it. Let's see one more. Now again this problem looks big. Okay, in exam when you see this, the first thing you will do is not to attempt this problem. Okay, but in remainders, try and go ahead to attempt such problems. So what will I do? Again it looks bigger. Whenever the problem looks bigger, what do? I try and identify the individual remainders for it. Okay, so what will I do now? I'll start with the first part. I'll start with the first part of this. Just give me a second. Yeah. Okay, I'll start with the first part of it. Yeah. So let's start with this. I'll start with this. 10 raised to 10 divided by 7. I need to find the remainder for this. Okay, then I'll find the remainder for this. The next part. Okay, 10 raised to 100 divided by 7. And I'll see if I can identify some pattern from it. So 10 raised to 10 divided by 7. How can I find the remainder for this? Denominator. I have a what? Prime number. What will I think of first? Format. I need 6 in the numerator. So I write 10 raised to 6 into 10 raised to 4 because I need to complete 10. According to format, the remainder for this entire thing is nothing but 1. 1 into 10 raised to 4 divided by 7. Now let's just cut this. 7 ones are 7. What am I left with? 3 0. 7 fours are 28. 2 0. 7 twos are 14. 6 0. 7 eights are 56. What's my remainder? 4. Okay, so I know the remainder for this is 4. I'll keep it like that. Now let's take the next part. 10 raised to 100 divided by 7. Again it's a 7. I need 6 in the numerator. So I write it. But since I have to complete 100, I'll write 16 into 6 is 96. Again I am left with 10 raised to 4 here. According to format, this is 1. 1 multiplied 16 times is nothing but 1. 10 raised to 4 divided by 7. The remainder for this is 4. And this will keep on repeating. Just see the pattern. 10 raised to 1000. Even if I take this, okay, what will happen here? 10 raised to 1000 divided by 7. 6 raised to 166. I am always left with 10 raised to 4. If I am always left with 10 raised to 4 divided by 7, in all the cases, I will always get the remainder as what? 4. Okay, so how many 4 I will get in this way? How many 4 I will get? How many zeros are here? 3, 3, 6, 7, 8, 9, 10. So I will get 4. How many times? 10 times. 4 10 times is nothing but my 40. Okay, 4 10 times is nothing but my 40. And 40 divided by 7, my answer will be what? 5. 7 5s are 35. So my answer for this is 5. So in remainder, when you get bigger problem, no need to worry because just solve individually and you will get the final answer for it. Let's move on to one more problem on remainders. Okay, so what is given here? 56 factorial plus 55 factorial plus 54, 53 up to 1 factorial divided by 56. For those of you who don't know what is factorial, 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. Similarly, what is 100 factorial? 100 into 99 into 98 up to what? 1. Okay, this will just go in this way. So let me just start up with this problem. I write it in reverse way. I start with 1. Okay, what difference it will make? Nothing. Okay, so I write it as 1 factorial plus 2 factorial plus 3 factorial going up to 56 factorial. So I just reverse the problem. Now, whenever you see a bigger number in remainder, what is the trick? Find out the individual remainder. So I try and find out the individual. 56 divided by 1. What will be the remainder? Since it is lesser than 56, the remainder will be same. So it is 1. 2 factorial divided by 56, remainder will be 2. 3 factorial, which is nothing but 3 into 2, which is 6. 6 divided by 56, remainder is 6. 4 into 3 into 2 into 1, right? 4 factorial. 4 into 3 into 2 into 1, which is nothing but 24. So 24 divided by 56, remainder is again 24. I go up to 5 factorial. 5 factorial is 5, 4, 3, 2, 1. 5 into 4 into 3 into 2 into 1. Okay, which is nothing but 120. So 120 divided by 56. Now there is a pattern here. Okay, 6 factorial. Okay, again let's find out 6 factorial as well. 6 factorial is 6, 5, 4, 3, 2, 1, which is nothing but 720. I come till here, I write all the numbers. From 7 factorial, I see a change. Now what is the 7 factorial? Let's observe this. 7 factorial is nothing but 7 into 6, 5, 4, 3, 2, 1. Divide this by 56. I am taking this part, okay? I am taking this part. Divide this by 56. Whenever I get a 7 and I get an 8, 7 into 4 into 2, right? 7 factorial will have a 56. Why? Because it has a 7 and it has an 8. 56 divided by 56, what will be the remainder? Remainder will be 0. Okay, you will ask me, sir, what is the quotient then? Multiply this. 6 5s are 30. 30 into 3, 90. So 90 is my quotient and my remainder in this case is what? 0. So from 7 factorial onwards, let's take 8 factorial as well. What will happen? 8 factorial is 8 into 7 into 6, 5, 4, 3, 2, 1. Right? Divide this by 56. I'll again get a 7 and a 8 here. So 7 into 8 is again 56. 56 divided by 56, the remainder will be 0. Quotient here will be 720. So what is happening? From 7 factorial onwards till 56 factorial, I'll get at least 1 7 and 1 8. And each of this factorial will have 7 and 8, 7 and 8. So each of the factorials starting from 7 factorial going up to 56 factorial will be completely divisible by 56, giving a remainder of 0. So rest of all of them will always till 56 factorial give me a remainder of 0. So what am I left with? I am left with a problem only till 6 factorial. So now, so the pattern is every time, okay, we get this, the same thing is being written here, it always gives a remainder of 0. So what is my problem reduced to now? My problem is reduced to this now, okay. So my problem is reduced to this now. Let's come to this. 1 plus 2 plus 6 plus 24 plus 120 plus 720. Let's add all of them. If I add all of them, the answer comes out to be 873. Okay. If I add all of them, it comes out to be 873. Divide this by 56. If you divide 873 now by 56, I get the remainder as what now? 33. Okay, so 33 is my final answer to this question. Okay, so what did I do? I added till 6 factorial, because till 6 factorial I am not getting any 7, so the remainder will not be 0. So add all of them, I get it to be 873, divide that by 56, I get the remainder as what? 33. Okay, and that is my answer to the question. Let's move on to one more hurdle problem which we can see on remainders. 7777, 37 times 7 divided by 19. How will I solve this now? So first I take out 7 as common. What am I left with? 1 1 1 1 1 1 7 times, right? This simple. If I write 77, take 7 as out, I can write it as 11, right? So same thing I had done, but this is 37 times. So I do it in this way, divided by 19. Now I write it in this way, okay? So this is the first step that should click you. Now how can I write 11? Imagine I can write it at 1 into 10 raised to 0 plus 1 into 10 raised to 1, right? What is 1 into 10 raised to 1? 10. 10 plus 1 is nothing but 11. If this was not 11, if this was 1 1 1, I can write it as 1 into 10 raised to 0 plus 1 into 10 raised to 1 plus 1 into 10 raised to what? 2. What is 10 raised to 2? 100. What is 10 raised to 1? 10. This is 1. Add all of them, it comes out to be 1 1 1. Similarly, I write this now. I write this. How many times do I have this? 37 times. So I'll write it as 1 into 10 raised to 0. Okay, going up to where? 1 into 10 raised to 36. How is this possible? See, if there are 3 ones, I go to 10 raised to 2. If there are 2 ones, I go to 10 raised to 1. So if there are 37 ones, I'll go up till 10 raised to 36. So I write it in same way. 10 raised to 0, 10 raised to 1, 10 raised to 2, 3, 4, 5, going up to 10 raised to 36, divided by 19. Then what do I do with this? I just write it, I reverse it, okay, I reverse it. 1 into 10 raised to 0 is 1. Okay, 1 into 10 raised to 1 will be, from here it will come out to be 10 raised to 1. 10 raised to 2 going up to 10 raised to 36 divided by 19. Now if you can observe, this is nothing but my GP, geometric progression. What is the geometric progression? Say 1, 2, 4. What is the common ratio here? 2. Okay, 2 by 1 is 2, 4 by 2 is 2. What is the sum of a series in geometric progression? It is A into r raised to n minus 1 upon r minus 1, right? Where r is my common ratio, n are the number of terms, and a is always my first term. I hope you know this. So from this I find my common ratio is nothing but 10 here. 10 divided by 10 raised to 2 divided by 10, my common ratio is 10. So what do I write? A, my first term. A, my first term is 1. This 7 remains as it is. My first term A, which is 1, into 10 raised to r. This is my r. R raised to n. How many terms are there? 1 to 36, 37 terms. So r raised to n. N is my 37. Minus 1 divided by n minus 1. So n is what my divided by r minus 1, right? So what is my r here? Common ratio 10. 10 minus 1 is 9 into 19, which remains to be here. So now the problem is reduced to 7 into 10 raised to 37 minus 1 upon 9 into 19. Okay, now I go for what? Chinese remainder. I take a 9 on one side, I take a 19 on the other. Now let's solve this. Okay, 10 divided by 9. 10 divided by 9, the remainder is 1. 1 multiplied 37 times 1. 1 minus 1, the remainder for this would be 0. So I know my LHS, the remainder is 0. RHS, I am happy. You know why? Because I get a 19, which is a prime number. So I'll apply what? Format here. So I'll see numerator mein what do I want? 18. So I write 10 as what now? I keep it like this. I write this as now 10 raised to 18 raised to 2. Okay, 18 into what? 36. Okay, and this 10 raised to 37. This remains out in this way. Now 10 divided by 19. Okay, 10 divided by 19. 10 raised to 18 divided by 19. According to format, the answer is 1. Okay, 1 multiplied twice. Okay, so what remains here? Nothing but 10 minus 1, which is 9. 9 into 7, which is nothing but 63. And 63 divided by 19 is nothing but 6. Okay, so what do I need in the end? I need a number. When I divide it by 19, it gives me a remainder of 6. So the number will be of the format 19x plus 6. And when I divide the number by 9, when I divide the same number by 9, the remainder is 0. Okay, so I need a number of this format. 19x plus 6 divided by 19, the remainder will be 0. Okay, try and put x as 1. It will be what? 25 divided by 9. No, I don't get it as I wanted. Try and put x as 3. Try and put x as 3. So this will be what? 19 3 the 57. 57 plus 6 is 63. 63. Okay, 63 when you divide it by 19, you know the remainder is 6. And 63 when you divide it by 9, you know the remainder is 0. I know that the answer is what? 63 to it. Okay, so just remember how I started. I started this problem by adjusting it. Then I applied the GP. I finally got the answer for the GP here. Okay, then I applied the Chinese remainder to split it up, and finally I got the answer in this way. Okay, so this was one hurdle. You can also see that as a peak point problem because this was difficult. Many concepts were used in the problem. Okay, but I hope this should clear most of your doubts related to remainders. Now last few problems before we start with the next lab. So this is 1 into 1 factorial, 2 into 2 factorial, 3 into 3 going up to 10 into 10 factorial. This is my P. What is he asking me? P, which means this plus 2 divided by 11 factorial. What is the remainder for this? Okay, so how will you start with this? I'll write this 1 as 2 minus 1. 2 minus 1 into 1 factorial plus this 2 as 3 minus 1. 3 minus 1 into 2 factorial. This 3 as 4 minus 1 into 3 factorial, and going like this up to, this is my what? 10. So I'll write it as 11 minus 1 into 10 factorial. Now what will I do? I'll multiply. 2 into 1 factorial is nothing but 2 into 1 factorial, which is nothing but 2. Okay, here. Then minus 1 factorial, which comes here. Similarly, I'll multiply 3 into 2 factorial, which will give me this, which is essentially nothing but 3 factorial. Minus 1 into 2 factorial is nothing but 2 factorial. I multiply this 4 into 3 factorial minus 3 factorial, and I do it till the end. So 11 into 10 factorial minus 10 factorial is what I'll get it in the end. Now what is happening here? These things are getting cut. 2 into 1 factorial is nothing but 2. 2 gets cut with this minus 2 factorial. Okay, because this is positive and this is negative. 3 into 2 factorial, which is nothing but 3 factorial. So this 3 factorial and this 3 factorial gets cancelled. 4 into 3 factorial is nothing but 4 factorial. This 4 plus 4 factorial minus 4 factorial gets cancelled. So what is the pattern here? This minus factorial is always getting cancelled apart from this minus 1 factorial. So also in the end my minus 10 factorial will get cancelled, okay, from the number which is coming in the previous. So what am I left with? I am just left with this two numbers in the end. After all the cutting, I'll just be left with this two numbers. Now what is this? 11 into 10 factorial is nothing but 11 factorial. So this will come here and minus 1 factorial. So I'm left with 11 factorial minus 1. So 90% of the problem is solved right now. What do I need? P plus 2. So what is my P? This 11 factorial minus 1, I write it here, plus 2. So I add 2 to this. 2 minus 1 is nothing but 11 factorial plus 1 divided by 11 factorial. 11 factorial divided by 11 factorial, the remainder is 0. Okay, 0 plus 1. My answer for this is now 1. Okay, so the difficult part about this problem was the first step. Okay, how will I split this up? How will I split this up to get the answer? Okay, once you split it up, you cut it, you get the final answer, and then you get the final remainder for it. Now this is one peak point problem on remainders that we can see. Okay, this is one marathon problem as well. Your Endeavor CAT student will be able to relate with this. Exercise 1, we can see this problem. Okay, so let's start with this. 1 raised to 1 plus 2 raised to 2 plus 3 raised to 3 plus 4 raised to 4 going up to 50 raised to 50, okay, is being divided by 8. The question is, what is the remainder for this? So whenever we see bigger number, what do? We try and split it up. So I find out the first remainder. 1 raised to 1 divided by 8, remainder is 1. 2 raised to 4, which means 4 divided by 8, the remainder is 4. 3 raised to 3, 27 divided by 8, okay. If you find it out by splitting it up, you will find the remainder as 3. 4 raised to 4 divided by 8, the remainder will be 0. 5 raised to 5, if you see, 5 raised to 5 is nothing but 5 square into 5 is 24 into 24 into 5, okay, which will again give me a 25 into 25 into 5, okay, so which will give me 25 divided by 8, 1 into 1 into 5, so remainder will be 5. For 6, if you see and split it up and get the answer, remainder will be 0. For 7, the answer will be 7. For 8, remainder will be 0. 9, remainder will be 1. 10, remainder will be 0, okay. You can individually find this remainder and see what is the pattern for it. 11, the remainder will be 3. 12, if you find it out, the remainder will be 0. 5 and then 0. So what is the pattern here? The pattern is every time, just forget this 2 raised to 2, which is 4. Every time I see an odd number, okay, I'll get a remainder of 1, 3, 5 and then 7. And even number will always give me a remainder of 0. So even number will always give me a remainder of 0 apart from 2 square, okay, apart from 2 square. Starting from 4 raised to 4, every time an even number comes, so let's say 14, after this 16, 18, 20, 22, 24, 26, 28, 30, this is how it will go on, 32, 34, 36, 38, 40, okay, 42, 44, 46 and then 48. All of them will give me a remainder of 0, okay, all the even numbers. And all the odd numbers will give a pattern. Pattern is what? 1, 3, 5, 7. Again, 1, 3, 5, 7 and so on. Okay, so this pattern will continue with the odd number. But let us just see the last odd number, 49 divided by 8. This will give me 1. Okay, which means that the pattern of 7 will end here. The pattern of 7 will end here. And I'll get an additional 1 here, which does not fit into the pattern of 1, 3, 5 and then 7. So what is the additional thing that I have got? Okay, even 50 raised to 50 will be 0. What is the additional thing that I am getting? The two circles. First 2 raised to 2, which is my 4. This does not give me a remainder of 0 in spite of being an even number. Second one, 49 raised to 49 divided by 8, which gives me 1 which does not fit into my pattern. Okay, so what is the overall remainder I got? 4 from 2 raised to 2 and 1 from 49 raised to 49. 4 plus 1 is 5. 5 divided by 8. My final answer for this is 5. Okay, so what did we understand from this? Again, in remainders, the problem look big. Okay, but there will always be pattern in it. Identify the pattern and crack the problem. So this is about your remainders. I hope you have certain questions related to remainders. So before I start with my lab 2, which will include factor and factorials, I'll take few of your questions related to remainders. क्या नाम है उसका? Okay, so Ankur has a question that I didn't get Chinese remainder. Could you explain it again? Okay, so I used Chinese remainder twice. I think there was some internet fluctuation as well while I was explaining Chinese remainder. So we'll go back to Chinese remainder. Let's go back to Chinese remainder. I'll just explain it to you in short so that at least you get a concept related to it. So what is a Chinese remainder? So Ankur, take, say I have a number n, okay, and I have a denominator, but I split up the denominator as x into y such that x and y are always co-prime to each other. Okay, what is co-prime? The highest common factor for x and y will be 1. And what do I see right now? I divide n by x, I find out the remainder for this. Then I divide n divided by y, I find out the remainder for this. Okay, so say the remainder in this case is a and the remainder in other case is b. Then I see what? Then I see a smallest number which when divided by x leaves a remainder of a and when divided by y leaves a remainder of b. Okay, so I think this looks theoretical to you, so I'll go to a problem. 128 raised to 100 divided by 153. So as it is being said, I split up 153 into x into y. So I write it as what? 17 into 9. Check it here. I write it as 17 into 9. Okay, then what do? I split it up. I find the remainder for this 128 raised to 100 divided by 17. I find out the remainder for this as well. 128 raised to 100 divided by 9. Now how did I find out this remainder? I applied Fermat theorem. But finally I got the remainder for this as what? 16. Okay, the first part. So first part I write it as 128 raised to 100 divided by 17 into 9. For the first part I got my remainder as what? 16. For the first part I have a remainder of 16. Okay, and now for the next part I'll go here. I think there is some glitch here. Is it coming? Okay, just give me a second. I think the screen is not working. Just give me a second. Found now. So let's start now. Next part I'll say this 128 raised to 100 divided by 9. Okay, I'll try and find the remainder for this. So I found out the remainder 128 raised to 100 divided by 9. I used my adjusting the power. I got the remainder as 7. Now this is I think where you would be confused. Now I need a number x. I need a number x when I divide this number by my 17. Okay, I need a remainder of 16. I need a remainder of 16. It means that number is of the form 17m plus 16, right? What is the smallest such numbers? Put m as 0, you will get as 16. What is the next smallest? Put m as 1. Okay, so it will be what? 16 plus 16, 32 plus 1, 33. But when I divide this same number by 9, I get a remainder of 7. Okay, so this number is of the form 9n plus 7. Okay, and I need smallest of such numbers. So if I put n as 0, it will give me 7. But if I divide 7 by my 17, I will not get the remainder as 16, right? So 7 cannot be the answer. Put n as 1. Put n as 1. So this will be what? 9 plus 7. This will be 16. Yes. 16 divided by 17, remainder is 16. Yes. And 16 divided by 9. Okay. 16 divided by 9, the remainder is 7. So 16 is the smallest of such number. When I divide by 17, I get at 16. When I divide by 9, I get as 7. Okay. So this is your Chinese remainder. So you always split up the denominator into two parts. You find out the remainder for individual parts and then you find out one of such smallest number which satisfied both the numbers when divided to get the respective remainders. Okay. So practice few problems. I had solved one more problem on Chinese remainder as well. That should give you an idea. So please just remember this theorem, okay, so that you will get a better idea of remainders. Okay, so this is about remainders. Okay, so this is about remainders. Now we'll go on to factors. Okay, and let's see what is it like we can see with respect to factors. Okay, so I'll just move on to lab 2 now, which is my factors. Yes, so I am assuming that you know basics related to factors and factorials. So lab 2 will include factorials and factors. Okay, so I'll first start again as we have started in remainders. I'll start with the basics of what are factorials. So what are factorials? As we have just studied, 5 factorial is nothing but 5 into 4 into 3 into 2 into 1. Okay, so what are factorials now? What am I asking you right now? I am giving you not 5 factorial, I am giving you 100 factorial. Okay, and I am asking you what is the maximum power of 2, 3, 5, 7 in 100 factorial. Okay, so let us simplify this. I am asking what is 5 factorial. You will say okay, 5, 4, 3, 2 and then 1. Now I am asking you what is the highest power of 2. What is the highest power of 2 in 5 factorial? So you will say okay, 2 cube. Why? 2 raised to 2 this, 2 raised to 1 is this. So this will be 2 cube into what? 5 into what? 3. Okay, so what is the highest power of 2 in this? Is nothing but 3. Highest power of 2 is 3. What is the highest power of 5 in 5 factorial? 1. What is the highest power of 3 in 5 factorial? Again 1. So I can find this out easily, right? The same question is asked on 100 factorial. If I write it as 100 into 99 up to 98, 97 up to 1. What is the highest power of 2 in that? What is the highest power of 3 in that? What is the highest power of 5 in that? Okay, so these are just basics related to it. Mirroring is stop. Just give me a second, guys. There is a glitch here. Because of internet issues here, so just bear us with this. So let's start. As I had taken the factorial part here, so I'll just move on to the factorials now. Yes, I am asking you now the basic. I hope this video is clear to all of you. In case you are not getting this video clearly, please reply in the comment section so that we can get it to the appropriate way. So let's start in this way now. So I'm asking you now, what is the highest power of 2, 3 and then 5 in 100 factorial? Okay, so we know it is easier to find in 5 factorial, but in 100 factorial. So I think all of you have learned this in class as well. I need the highest power of 2 in 100 factorial. So first start with this, divide 100 by 2. What do you get? 50. Okay, then what do you do with this? You divide 50 by 2. Okay, then I get a 25 here. So then I get a 25 here. Yes, then I get a 25 here. Then you divide what? Then you divide 25 by 2. What is 25 divided by 2? You get a 12 here. Then you divide 12 by 2. You get this here. 12 divided by 2, it is 6. Then I divide 6 by 2. Okay, what do I get here? 3. Then I divide 3 by 2. What do I get here? 1. Okay, so till what time am I supposed to do this? Till I get this number which is lesser than my denominator. Yes, 1 is less than 2. Now add all of them. Add all of them. 50 plus 25 plus 12 plus 6 plus 3, which will give me 97. So I know what is the highest power of 2 in 100 factorial? 2 raised to 97. Similarly, I need to find highest power of 3. So divide 100 by 3. 100 divided by 3 is nothing but 33. 33 divided by 3, 11. 11 divided by 3 is 3. 3 divided by 3 is 1. Add all of them. 33 plus 11 plus 3 plus 1 is 47. So what is the highest power of 3 in 100 factorial? Okay, 3 raised to 47. Okay, if you can compare, we are doing it in the same way. Now 100 divided by 5. Okay, so I need to find out the highest power of 5 in this as well. So divide 100 by 5 is 20. 20 by 5 is 4. So what do I get? 20 plus 4 is nothing but 24. Okay, can I find the highest power of 6 in this way? No, because this way you can find the highest power of only the prime numbers. only the prime numbers, okay, but not of any other number. So if I ask you for 6, then the question would be different, okay. But till now we know the highest power of 2 is 97, 3 is 47 and 5 is 24. So let's move on to the next part. Now I am asking you, what is the highest power of 6 in this? Yes. What do you need to form 1, 6? You need 1, 2 and 1, 3. How many 2's I have here? How many 2's? Let's take it 97. How many 3's do I have? 47. So I have 47 3 and I have 97 2's. How many 6 can you form from this? By logic you will say what? 47. Okay, if I have 2 raised to 10 into 3 raised to 30, how many 6 can you form? 10, right? Why? Because the highest power, because you will need always a 2, right? And maximum 2's that I have are 10. So how many 6 can I form here? 10. Okay, similarly if I ask you what is the highest power of 12 in this, okay, what is the highest power of 12 in this? So you will start, okay, what do I need to form a 12? I will need 2 2's. I'll need 2 2's because this is 4. So I'll write this as 2 raised to 48 into 2, okay, which is 97 into 3 raised to what? 47. Okay, how many 4's do I have here now? How many 4's do I have? 48. Okay, and how many 3's do I have? 47. So how many 12's can I form? 47. Okay, because I need 1 4 and 1 3 to form 1 12. Okay, and that is what gives me the idea. Similarly, if I ask you what is the highest power of 24, you will write, okay, 2 raised to 3. Okay, raised to what? I'll write 2 raised to 3. So this is 3 3's are 9. This is 32. 32 into 3 is 96. 1 2 will remain here. And what is 3 raised to 47? So what do I need to form 24? I need 1 8 and I need 1 3. How many maximum 8's do I have? 32. So how many 24 can I form? 32. So what is the highest power of 24? Okay, in my 100 factorial it will be 32. Okay, in this way you can just keep on finding the highest power of 32, highest power of 48 and so on. Okay, so you can just apply the previous method only for prime numbers. For the numbers which are composite, you will have to split them in terms of prime number and then see their highest power. So similarly, I ask you, what are the number of trailing zeros at the end of 100 factorial? Trailing zeros. What do you mean by trailing zeros? What is 5 factorial? 120. Number of trailing zeros at the end of 5 factorial? 1, right? So similarly, if I write, I multiply all of them, 100 into 99 into 98 up to 1. I am asking you what are the trailing zeros at the end of this, okay? So that is my question. The number of zeros will depend upon number of 5's and 2. So what do I need to form 1 0 which is 110? I need 1 5, I need 1 2. If I have 2 5 and 2 2, they will give me 210. If I have 3 5 and 3 2, it will give me 310. If I have 13 5 and say 3 2, it will give me how many 10? It will again give me 310. Why? Because the maximum 2's that I have are 3. So similarly, we'll start with this. I am asking you number of zeros at the end of 100 factorial. So how many 5's do I have? 24. How many 2's do I have? 97. So how many zeros will I have at the end of this? Maximum I have 24. So 24 trailing zeros will be there at the end of 100 factorial. Okay, so this gives me the answer to the question. Now let's start with few early checkpoints. Now this was just the warm up, brushing up the basic concepts related to factorials. Now we move on to a problem. What is the problem asking me? Find the total number of trailing zeros at the product of first 100 multiples of 5. Okay, what are the number of zeros at the first 100 multiples of 5? So what is the first multiple of 5? 5 into 1. Second 5 into 2. Third 5 into 3. 5 into 4. 5 into 5. Going up to 5 into 100. What do I do right now? I take all the 5's on one side. How many 5 do I have? 1, 2, 3, 4, 5. Going up to 100, right? So I take all this 5 out. This turns out to be 5 raised to 100. What am I left with then? What am I left with? I am left with this 1 into 2 into 3 into 4 into 5 up to 100. So I write it here. 1 into 2 into 3 into 4 up to 100. But this is nothing but what? 100 factorial. 100 factorial is nothing but 100 into 99, 98, 97. Yes, so this entire thing turns out to be 100 factorial. And this is nothing but 5 raised to 100. So let's write it here. In 100 factorial, what is the highest power of 2? We just found out, 97. In 100 factorial, what is the highest power of 5? We just know, 24. What do you need to find out trailing zeros? The question is asking trailing zeros at the product of this, right? So to form a trailing zero, I need 5 and then 2. How many 5's do I have? 124. How many 2's do I have in this complete thing? 97. So how many zeros will I have? 97, as we have just learned, right? You need a 5 and the 2. The maximum 2 that I have are 97. So maximum zeros, or the total number of zeros that I'll have at the product of first 100 multiple of 5 will be 97. Now let's take one more problem. Okay, Endeavor student will again be able to relate to you. This is a marathon problem. So what is given here? 2 factorial raised to 2 factorial, 4 raised to 4 factorial raised to 4 factorial, 6 factorial raised to 6 factorial, 8 factorial raised to 8, and 10 factorial raised to 10 factorial. How many zeros will be there at the end of this product? Okay, and what do I need to form a 0? I need a 5 and a 2. So I need to find out what is the highest power of 5 in this. I need to find out what is the highest power of 2 in this. And I'll get what is the number of zeros at the end of this product. So let's start. 2 factorial could be written as 2 into 1. 4 factorial 4, 3, 2, 1. 6 factorial 6, 5, 4, 3, 2, 1. So I write this entire thing. 8 factorial 8, 7, 5, 4, 6, 3, 2, 1. 10 factorial could be written as this, raised to 2 factorial, 4 factorial, 6 factorial, 8, and then 10. Now I need to find first 5 here because I know 2 will be maximum here. I just need to find out 5. By observation I can see there will be 2 here, there will be 2 here. Maximum 2s I will get it. Minimum 5s I will get it. Okay, and the number of 0 now will depend upon the number of 5 because 5 are minimum here. So what will I do? I will write how many 5s here? 5 raised to 6 factorial, right? So how many 5s in this? 5 raised to 6 factorial. Okay, so I have 6 factorial 5 in this. Can you imagine? 6 factorial. 6 factorial was 720. So I get 725 from here. Now this is what? One more 5 here. 5 raised to what? 8 factorial. Which means how many 5s do I have? 8 factorial times. 8 factorial times I have 5. Now this is what? 5 raised to 10 factorial. So how many 5s do I have? 10 factorial times 5. Okay, 10 factorial times 5. But there is a catch here. There is one 5 here and there is one more 5 that I will get from 10. So there are 2 5 in 10 factorial itself, right? 2 5s here. So I will write this as 5 raised to 2 because there are 2 5s here. One from this, raised to 10 factorial. So how many 5s do I get from here? 6 factorial 5s. From here 8 factorial times 5s. And from here 2 into 10 factorial times 5. Okay, and this is the maximum. This is the number of 5s do I have here. 6 factorial plus 8 factorial plus 2 into 10 factorial. How many 2s will I have? Definitely more than this. So how many zeros will I have? Okay, how many zeros will I have? Minimum number of this is this, right? So the number of zeros that I'll have is 6 factorial plus 8 factorial plus 2 into 10 factorial. This will be my number of zeros at the end of product of this number which is given to me. Okay, so I hope this clears your doubts with factorials. Let's come on to one more problem now. This is my peak point on factorials. One of the most difficult problem that I can get on factorials. What is the question asking me? Number of zeros at the end of this. So I start with this. 1 raised to 1, 2 raised to 2, 3 raised to 3, 4 raised to 4, 5 raised to 5, and then 6 raised to 6. Going like this up to what? 100 raised to 100. And the question is asking me how many zeros at the end of this. So what do I need here? I need what is the maximum power of 5. I need what is the maximum power of 2. Again by observation, what can I say? 2 here would be my maximum. Okay, 2 here would be my maximum because there are so many even numbers here. 5 here would be my minimum. So what will I do? I will not find the power of 2. I will just find the power of 5 here. Because that will give me now again what are the number of zeros in it. Okay, so let's find out what is the maximum power of 5 that I can get at the end of the product of 1 raised to 1, 2 raised to 2, 3 raised to 3 going up to 100 raised to 100. So I write them in this way: 1 raised to 1, 10 raised to 10, starting 11 raised to 11, 20 raised to 20, and going like this. Where is it like I am getting 5? 5 raised to 5, right? 5 raised to 5 will give me 5 5s, yes. 10 raised to 10, which will have 1 5. Okay, so this will again give me what? 10 5s. So this give me 5 5s. Similarly, 15 will give me 15 raised to 15. This has 1 5 in it. So 5 raised to 15, which means this will give me 15 5s. This will give me 20 5s. Similarly, 25 is a catch here. 25 is nothing but 5 raised to 2 raised to 25, right? Because 25 has already 5 2s in it. Sorry, 2 5s in it. 2 5s raised to 25. So this will not give me 25 5. This will give me 55s, okay, which is more 25. So I should have ideally got a 25 here, but I got a 50. Okay, similarly 30 will give me how many 5s? 35. 35 will give me 35. 40 will give me 45, will give me 45 5. 50, 50, which is nothing again but 25 into 2. It should have given me 55, but it will give me 100, because I can write this is 25 into 2 raised to 50. Okay, 5 square into 2 raised to 50. So this will become 50 into 2. How many? 100. So is there a pattern here? Every multiple of 25 will give me double the number of 5. So 25, 50, 75. 75 should have given me 75 5, but it will give me 150. And the last will be 100. 100 should have given me 100 fives, but it will give me 200. So what is this? If I have to add, this is 5 fives plus 10. 5 plus 10 plus 15 plus 20 plus 25. But this 25 is nothing but 50, right? Because 25 is giving me 50. This is nothing but an AP. If I have to add them, 5 plus 10 plus 15, this is nothing but an AP. 5 plus 10 plus 15 plus 20 plus 25 going up to 100. Okay, the only concern here is this additional 25 I am keeping it outside. This additional 50 I am keeping it outside. Because if I take this, it will not fit into my AP. Okay, this additional 75 I am keeping it outside. This additional 100 I am keeping it outside. Okay, and I am making an AP out of it. How am I making? 5 plus 10 plus 15 plus 20 plus 25. I didn't take it as 50. I'll take the more 25 in the end. Okay, plus 30 going like this up to 100. So if I make an AP out of it, okay, what is sum of AP? First term plus last term. 5 plus 100 will give me 105 into number of terms, which are nothing but 20 terms. 25 is 100 divided by 2. 105 into 10 is nothing but 1050. But we had not taken the additional because I wanted to make an AP out of it. So let's add those additional 25 plus 50 plus 75 plus 100. 25 plus 50 plus 75 plus 100 gives me 250. 250 plus 1050 gives me 1300. And these are the number of fives that I have here. Number of fives. How many 2 do I have? Maximum. So I won't take this. This will give me the number of zeros. So what will be the number of zeros at the end of this? 1300. Okay, so that gives me the answer to the question. Okay, so whenever asked number of zeros, identify the maximum power of 5 and then 2. Okay, 5 into 2 will give me 10, which will give me my 0. So I hope this cleared most of your doubt related to your factorials. Now next we start in lab 2 is factors. Okay, now let's start with factors. What are factors? First, let's see that. Okay, so I'll give you one simple number 8. What are the factor of 8? 1, 2, 4 and then 8, right? Similarly, I'm asking you what are the factors of 120? For some of you who don't know factors, factor is a number. If I divide this number by 2, which is its factor, the remainder will be 0. Okay, so what are the factors of 8? 1, 2, 4, 8. If I divide 8 by all this number, the remainder will be 0. So if I am asking you what are the factors of 120? What are the factors of 120? These are all. Okay, 1, 2, 3, 4. If you divide 120 by any of this number, the remainder will be what? 0. Okay, so I know 1, 2, 3, 4, 6, 8, 10, 12, 20, 60, 120 are all what? Factors of 120. But I cannot write it all the time in this way and identify what are the number of factors of 120. So I need some shortcut formula for that. So what is this? I write 120 in terms of prime numbers. Okay, this is just a warm-up problem for some students who don't know what exactly are factors. So this is just a warm-up problem for them. Okay, so what will I do? I'll write 120 in terms of 3 prime numbers. 2 into 3 into 5. 8 into 5 is what? 40. 40 into 3 is 120. Now what will I see? Okay, this is my 8. How many factors are there for this 8? 4, right? 2 raised to 0, which means 1. This is 2. This is 4. This is 8. So 4 factors. 4 factors for 8. How many factors for 3? 3 has how many factors? 1 and then 3, only 2 factors, right? So 2 here. How many factors for 5? 5 raised to 0 and 5 raised to 1. So 2 factors here. 4 into 2 into 2 is nothing but my 16. Yes. So I won't write this all the time. Okay. If I have been asked number of factors for any number, what will I do? I'll write that number in terms of prime number. And I'll identify what are the number of factors are there for that prime number. Okay. So for 8, 4 factors. For 3, 2 factors. For 5, 2 factors. 4 into 2 into 2, total number of factors are 16. So I make a formula out of it. What is the formula? I write it in terms of a raised to p, b raised to q, c raised to r. Now what is a according to this problem? It is 2. What is p? It is 3. What is B? 3. What is Q? 1, because this is 3 raised to 1. What is C? 5. What is R? 1, because this is 5 raised to 1. And what will be my number of factors? P plus 1 into Q plus 1 into R plus 1. So this is what? 3 plus 1, which is 4. Okay, 1 Q plus 1, which is 2. R plus 1, which is 2. 4 into 2 into 2. So whenever asked number of factor, this is the form. Now I am asking you, what is the sum of factor? What do you mean by this? Add all of them. Add all of them. 1 plus 2 plus 3 plus 4. Keep on adding it like this. What will be the sum of the factors? Okay. So this will again be simple. How can we do this? There is again a formula for this. Now always, since we have written it in the form a raised to p, b raised to q, c raised to r, sum of the factors is a raised to p plus 1 upon a minus 1 into b raised to q plus 1 upon b minus 1 into c raised to r plus 1 upon c minus 1. So I already know what is my a, b, c. If you can see it, a is 2, b is 3, c is 5. So 2 raised to 3 plus 1 upon 2 minus 1, 3 raised to 1 plus 1, 3 minus 1, 5 raised to 1 plus 1 upon 5 minus 1. So if I cut it, I get it as 550 into 9, which is nothing but 450, which is my sum of the factor. So in case ask sum of the factors, use the formula, write the number in terms of prime numbers, write it in the form a raised to p, b raised to q, c raised to r, find the final answer. Next question is product of factors. Now what is the meaning of this? Multiply all of them. 1 into 2, 2 into 3, 3 into 4, 4 into 5, and then so on. Okay, what will be the product of factors? Now let's do it smartly. We'll multiply, but we'll multiply it smartly. Let's multiply first and the last. 1 into 120 is what? 120. 2 into 60 is what? 120. 3 into 40 is what? 120. How many 120 will I get it in this way? I'll get it for this, I'll get it for this, I'll get it for this, I'll get it for this as well. So how many 120? Each of the two factor. How many factors are there? 16. Each of the two factor will give me what? 120. So how many 120 will I get? 8. I'll get 8 120s, okay, and that is my product of factors, 120 raised to 8. If asked in terms of formula, how will I write this? I'll come here. If asked in terms of formula, I'll come here and I'll do this, okay, which is nothing but n nothing but my number, 120 raised to number of factors divided by 2. So 120 number of factors are 16. 16 divided by 2 is nothing but 8. And that is my answer to the question of product of factors. Now I am asking you next question. How many are odd factors? Okay, so how many are odd factors in 120? So let's just come here. How many are odd factors here? So if you can just observe it here. Okay, how many are odd factors? So I can see 3 as one odd factor. I can see 5. What else odd factor? I have 1 here. Okay, and that's it. I have this, which are my odd factors now. Again from this 1, 3, 5. Okay, so I am asking you this question. How many are odd factors here? So you will come to this and you will see to this. See, whenever asked for odd factors, what do? Take out 2's. Take out all the 2's. Okay, we know that number of factors for this was 4 into 2 into. So I take out this 4. What am I left with? 2 factors of 3 and 2 factors of 5. So 2 into 2, number of odd factors will be 4. If you want to visualize this, this is 1, this is 3, this is 1, and this is 1, and this is my 5. So multiply first. 1 into 1 will be 1. 1 into 5 will be 5. 3 into 1 will be 3, and 3 into 5 will be 15. Okay, so how many odd factors do I have? 1, 3, 5, and then 15. 1, 3, 5, and then 15. I had missed the 15 here, I think. So that was the only problem. I had missed the 15 here. So you can consider between 12 to this 15. So how many odd factors are there? 1, 3, 5, and then 15. Okay, so I had missed the 15 here. Please make a correction on this as well. Yes. Now how many factors I am asking are divisible by 2 or a 3 or a 4 or a 6 or a 8 or a 10. So what will I do? You write first 120 in terms of this. Just take out 2 out of this. If I take out 2 out of this, what am I left with? I am left with this 2 square. 2 square. How many factors does this add? 3. How many factors this has? 3. 2. How many factors this has? 3 into 2 into 2 is nothing but 12. So there are 12 factors which will be divisible by 2. So whenever I ask you how many factors are divisible by a particular number, take that number out here. Whatever will be left, whatever factors will be left, those factors will always be divisible by that number. So how many factors are divisible by 3? So I take out 3 from here. What am I left with? 2 raised to 3 into 5. 2 raised to 3 has 4 factors. 5 has 2 factors. 4 into 2, 8. 8 factors will be there which will be divisible by 3. If I ask you how many factors are divisible by 4, okay, take out 2 square out. 2 square out, what am I left with? 2 into 3 into 3. How many factors 2 has? 2. How many factors 3 has? 2. 5 has 2. 2 into 2 into 2, 8. How many factors are divisible by 6? Take 1 2 out and 1 3 out. What am I left with then? 2 square into 5. 2 square has 3 factors. 5 has 2 factors. Okay, so 3 into 2, 6 factors will be divisible by 6. Similarly, if I ask you how many factors are divisible by 8, take 2 cube out. Okay, what am I left with? 3 into 5. So this has 2 factors, this has 2 factors. 2 into 2, 4 factors. If I ask you how many are divisible by 10, take 10 out. 1 2 and 1 5. What am I left with? 2 square and 3. 2 square has 3 factors, 3 has 2 factors. 3 into 2. 6 factors are then divisible by my 10. So this gives you a complete warm-up related to factors. So what do you need? First, number of factors you know. You know how to find out sum of factors. You know how to find out product of factors. You know how many factors are odd. You know how many factors are even. Yes, now let's move on to this. Odd factors, even factors and perfect squares. So let's come to this now. So divisibility by 2, 3, we know that. Okay, we know how many of them are odd and even, right? I didn't cover this. Okay, how many odd factors are there? We know that it's of 4. If I ask you how many even factors are there, this would be simple, right? Total number of factors are 16, odd factors are 4, so even factors will be what? 12. Okay, so this should also be simple. Now I am asking you, how many factors are perfect square? Yes. How many factors are perfect square? So let's come back to this. How many are perfect square here? So my perfect square here is first 1, yes. Then I have a 4, yes. Then I have a, that's it. I have two numbers which are perfect square, right? So can I get this answer by formula? How many factors are perfect square? Whenever asked for perfect square, check this out. 8 has this many factors, 3 has this many 5. So perfect square would be this and then this. So how many factors from here? 2. Perfect square here is only 1, so 1. Perfect square here is only 1, so 1. 2 into 1 into 1, 2. I have two factors which are perfect square. Okay, similarly I'll ask you perfect cube. How many factors are perfect cube? So let's come back to this. How many factors are perfect cube here now? Perfect cube, 1 is a perfect cube as well as a perfect square. 8, right, is a perfect cube. So I have two factors which are my perfect cube. If I want to solve this by formula, how will I solve this? Now let's come to here. How many factors are perfect cube? So what is a perfect cube here? 1, and other is an 8 in this. How many are perfect cube here? 1. How many are perfect cube here? 1. So 2 into 1 into 1, which is again my 2. So I get two factors which are my perfect cube here. Okay. So whenever it is being asked about a perfect square or a perfect cube, you go with this method. So now we know what? We know number of factors. We know how to find out sum of factors. We know how to find out product of factors. How many factors are odd? We know how to find it out. How many factors are even? We know. How many factors are perfect square and perfect cube? So this completes our warm-up related to factors. Okay, we know the basic concepts of factors. Let's start with the early checkpoint on factors now. So we start with a hurdle problem on factors. Even factors for this number. Now 120 was a smaller number. We split it up in terms of prime numbers. Now I am giving you a number. Okay, now I am giving you a number as this. 2 raised to 7 into 3 cube into 5 raised to 4, and I am asking you how many even factors for this. Okay, so how many factors for this? 2. These many factors, which includes 8 factor. How many factors for this? 4. How many factors for 5? Nothing but a raised to p into b raised to q into c raised to r, right? Of this form. P plus 1, q plus 1, r plus 1. So 7 plus 1, 8, 3 plus 1, 4, 4 plus 1, 5. Total number of factors are 160. But what did I ask you? Even factors for this. Okay, so what will you do? First find out odd factors. To find out odd factors, I'll cut this. I don't want any factor of 2. So how many left factors are left? 4 from here, 5 from here. Total number of odd factors are 20. Okay, but total factors are 160. Out of them odd are 20. So even is what? 140. That's it. That gives me the answer to the question. How many factors will be even factors in this number? Okay, so I found out odd. Total minus odd gave me the answer for even number of factors. Okay, let's go for the next now. So the next is this. For the number this, the total number of perfect square factor is. Yes, we also know how to find out perfect square. So I wrote 2 raised to 7 as what now? This. I wrote 3 raised to 5, these many factors, 5 raised to 10, these many factors, and 7 raised to 2, these many factors. Now I need to find out perfect square. So let's start. How many perfect square here? 1 is a perfect square, 4 is a perfect square, 2 raised to 4, 2 raised to 6, right? All perfect square. So I got 4 from here, 4 from here, which are perfect square. Again I got 3 from here, 3 raised to 0, 3 raised to 2, 3 raised to 4, 3 are perfect square. From here I got 5 raised to 0, 5 square, 5 raised to 4, 5 raised to 6, 5 raised to 8, and 4, 5. Okay, 1, 2, 3, 4, 5, and then my 5 raised to 10. Okay, so I will have this what? So we'll just change this. Okay, so how many are perfect squares? So let's start with this. So how many? 1, 2, 3, 4, 5, 6. So I'll have 6 here. How many are again perfect square here? 1 and then 2. So this is 2. Now let us just multiply. 4 into 3, 12. 12 into 6 is 72. 72 into 2 is 144. So these many factors are perfect square. Okay, so that's how we knew the method. We just wrote it down. We found out how many are perfect square, and then we get the eventual answer for this. Number of factors, if asked, it would be 8 into 6 into 11 into 3. Total number of factors are this. Out of this, perfect square are these many. Okay, so not every time you will get a number like 120. 120 was just to explain you the concept related to it. Okay, but after that you will always get difficult problem related to your factors. Now let's move on to the next problem. Again, my next problem is on factors. This is asking me what is a product of factor of this which are perfect square. Now that is my hint. He is not asking me a plain product of factors. What would have been that been? So I write how many factors for 2 raised to 10? 11. How many factors for 3 raised to 8? 9. 11 into 9, total number of factors are 99. How do you find out product of factors? We have learned. Okay, for 120 we did 120 raised to 16 divided by 2. Number of factors divided by 2. So we got the answer at 120 raised to 8. But he is not asking me total number of factors. He is asking me product of factors which are perfect square. So how many factors are there first of all which are perfect square? So I'll get perfect square 1, 2, 3, 4, 5, 6. So 6 here. From here I get 1, 2, 3, 4, 5. So 5 here. 6 into 5. 30 factors are there out of 99 which are perfect square. If I want a product of this, what do? You write the number n, you write the number of factors. In this case, it will not be 99 because I don't want all the factors. I want perfect square divided by 2. Right? Because each of the 2 factor will form one product. So I write the number, I write the same number here as 2 raised to 10 into 3 raised to 8. I don't write total number of factors. I write the factors which are perfect square, which are 30. So 30 divided by 2 is 15. That's it. This is my answer now. 2 raised to 10 into 3 raised to 8 raised to 15 are the number of factors, okay, product of which is my perfect square. Okay, so I applied the same concept, but it is just that it is being asked in a different way. Okay, Endeavor student will be able to relate to this. Okay, this was OMC 3 problem which came in the paper, which was one of the peak point problem that you could see on factors. Okay, so I see one more problem now. This is again a peak point problem on factors. This problem doesn't involve much of calculation, but it requires understanding of factors. So what is the problem stating now? There are 231 doors in a building, numbered from 1 to 231. Okay, understood. All of which are initially closed. A person opens all doors whose number are multiple of 3. Okay, so first of all, the person comes and opens all the doors which are multiple of 3. Okay. Then he opens all the doors which are multiple of 7. Okay. Then he opens all the doors which are multiple of 11. Okay, how many doors remain closed? Now this is one application of factor. Okay, so what will I do here? So I'll tell you 30. Okay, how many multiples of 3 are there in 30? You will say, okay, divide this by 3. The answer is what? Answer is what? 10. I have 10 multiples of 3 in 30. Okay, I am asking you how many numbers are there in 30 which are not the multiple of 3. So you will say, okay, this is 30 minus 10, 20, right? Or else I could have done it in this way. Okay, in 30, I want all the numbers which are not the multiple of 3. So I'll write 30 into 1 minus 1 by 3, which is nothing but 30 into 2 by 3, which is nothing but 3 ones, 3 tens, 10 into 2 is nothing but 20, the same answer which we got. Right? So if I want to know in till the number 30, how many numbers are there which are not the multiple of 30, I'll write it in this way. So he opened all the doors which are multiple of 3. So I don't want multiple of 3 because he has opened all those doors. What is he asking? How many doors remains closed? So all those which are not the multiple of 3 will remain closed. So I write it as, okay, there are 231 doors, right? What will remain closed? 1 minus 1 by 3. All the numbers which are not the multiple of 3 will remain closed. Then all the numbers which are not the multiple of 7 will remain closed. Then all the numbers which are not the multiple of 11 will remain closed. Right? The similar way I solved it here. But since instead of 30, you have a 231 here. So I solved this 2 by 3, 6 by 7, 10 by 11. I just cut this 7 3s are 21, 21 11s are 11, 11 gets cancelled. 12 into 10, 120 is my answer. So 120 doors will remain closed, okay, because 120 are the numbers which are neither a multiple of 3, neither a multiple of 7, neither a multiple of 11, okay. So this was again one application of factors that you could have used. This is again one of the problem based on the same application. Now what is this now? Now this problem states that there are 100 doors in a room, okay. The first person comes and opens all doors which are multiple of 1. Understood, okay. If all doors are closed and he comes, initially all doors are closed, okay, that's an assumption. He comes and opens all doors which are multiple of 1. So essentially he has opened all the doors, because all the numbers from 1 to 100, if I say door number 1 is number 1, door number 2 is number 2, door number 3 is number 3, up to door number 100 is my number 100. So he has opened all the doors, okay, because all of them are multiple of 1. Second person goes and closes all the doors which are multiple of 2, okay. So what is he doing? He is closing all the doors which are multiple of 2. So door number 2 is closed, door number 4 is closed, door number 6 is closed, and then so on. Third person goes and he performs the reverse operation. What will he do? He will open or close, okay. So the doors which are open he will close, and the doors which are closed he will open, okay, for all those doors which are multiple of 3, okay, for all those doors which are multiple of 3. Fourth person goes, he performs the reverse operation. The doors which are open he will close, and the doors which are closed he will open, but he will do it for all those doors which are multiple of 4. And this happens till when? This happens till the 100%. 100% goes in and then he performs the same operation. The doors which are closed he will open, the doors which are open he will close, okay, and he will always do it in the multiple of the person that is entering. So if the 8th person is entering, he will do what? Open or close, okay, perform the operation on the doors which are multiple of 8. So what is the question is asking me? How many doors will remain open after the 100th person come out? Okay, so how many doors will remain open? Now we know that some are opening the doors, then they are closing the doors as well, right? So all the doors which have odd number of factors will remain open. Okay, now let's see how. Say my number is say 2 square, okay, which is say 4. How many factors are there for 4? How many factors are there for 4? 1, 2 and then 4. So what will happen with this? So number 1 entered, okay, he opened the door. Number 2 entered, he closed the door. Number 3, okay, which has 4 will come and again open the door. So whenever I get odds, okay, so again say start, okay, a number which has 5 factors, numbers which have 5 factors. So what will happen here? Say 1 will open the door, second will close the door, third will open, fourth will close, fifth will again open. If it has 7 factors, a number which has 7 factors, it will be open, close, again close and open. So any number that has odd number of factors will have the doors to be open, because eventually it will be open. And what do we know? Only perfect square have odd number of factors. Okay, so let's see. 1 square 1, how many factors to this? 3. How many factors to 4? 3. How many factors to 9? Again you can see 3. How many factors to 16? 5. How many factors to 25? 3. How many factors to 36? 9. 49? 3. 64? 7. So all the doors which have the number as perfect square will have odd number of factors, and all the odd number of factors will have the door as open, because eventually it will be what? Open, close and open. So how many are there? Just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 doors will be opened in the end. Okay, so this was again one application of factors. Only the numbers which will have odd number of factors will have the doors to be open, and only perfect squares have odd number of factors. Okay, so this was one application. If you knew this concept, you would have got this problem. Now we start with our lab 2, the last part of it. I'll just revise through it very basically, because unit digit, I hope all of you know this. So I'm asking you 2 raised to 2019. We are done with factors and factorials. We'll finish with unit digit and then we'll move on to the lab 3, which is my LCM and HCF. So let's start with this now. Unit digit, I hope you know that 2 raised to 2019, what is a unit digit? So 2 has a cyclicity of 4. After every 4 power, the unit digit gets repeated. So just divide this by 4. 4 4s are 16. This is similar to 2 raised to 3, right? And 2 raised to 3 ends in 8. Right? I'm just revising through this because this is one concept on cyclicity that you need to know. 2 has a cyclicity of 4. Okay. So similarly, your 3 has a cyclicity of what? 4. After every 4 power, the unit digit gets repeated. So if I ask you what is 3 raised to 13, what will you do? You will divide this by 4. Okay, divide this by 4. So what is the remainder that is coming out to be? 4 3s are 12. Remainder is 1, which means 3 raised to 13 is similar to 3 raised to 1. Okay, and 3 raised to 1 ends in a 3. So 3 raised to 13 will also end in a 3. In short, any number that is given to you, and I am asking you what is the unit digit of 3 raised to 2017. What will you do? Divide 2017 by 4. Why? Because 3 has a cyclicity of 4. Check the remainder for it. Last two digits, 17 by 4. The remainder is 1. Okay, if the remainder is 1, this is similar to 3 raised to 1. 3 raised to 1 ends in a 3, so this number will also end in a 3. Okay, in short, however bigger number is given to us, we make that number to come out in terms of this 4 numbers. Okay, this 4 numbers, because this 4 numbers always get repeated. Okay, so if we know the answer for this, we know the answer for that bigger number as well. Similarly, what is the cyclicity of 7? It is again 4. If you can see, after every 4 power, the unit digit gets repeated. So I am asking you what is the unit digit of 7 raised to 2008. Divide this by 4. Remainder is 0. Yes. So when you get remainder as 1, this is the answer, 7 raised to 1. When you get remainder as 2, this is the answer. When you get remainder as 3, this is the answer. When you get remainder as 0, last part, 7 raised to 4 is the answer. Okay, so what will be the remainder for this? It will be 1. Okay, so I know this as well. Just basic concept, brushing up through this. Again, 8 has a cyclicity of 4, which means after every 4 power, the unit digit gets repeated. So what will be the unit digit of 8 raised to 2017? Divide this by 4, remainder is 1. 8 is similar to 8 raised to 1. So again, it has a unit digit of 8. In short, however bigger number is given to you, make that number to come in terms of this 4, because always this 4 gets repeated. And if I know the answer for this 4, I know the answer for that number as well. Okay, so let's start with the next part of it. Similarly, 4 and 9 has a cyclicity of 2. So every 2 after 2 power, the unit digit gets repeated. So if I give you 9 raised to 20, divide this by 2, the remainder is 0, so the answer is 1. Or you can say whenever you have an even power, the remainder will be 1. Sorry, not the remainder, but the unit digit will be 1. Whenever you have an odd power, the unit digit will be 9. Similarly, for 4, odd power will give you a unit digit of 4. Even power will give you a unit digit of 6. 5, 6 and 1 has a cyclicity of 1. So 5 raised to anything, unit digit is 5. 6 raised to anything, unit digit is 6. 1 raised to anything, we know that the unit digit is 1. This is one basic problem that you can get on this. Find the unit digit of this expression. So what will I do for this? I'll just find out the individual unit digit. For example, I ask you what is the unit digit of 12 into 12 into 12? You will say this is 12 cube 1728. I am not asking you this. I am asking you unit digit of this. So you will say take unit digit of this, which is 2. Take unit digit of this, this is 2, this is 2. 2 into 2 into 2 is nothing but 8. That is a unit digit of the complete expression. So similarly, I'll start from here. What is a unit digit of 6? 6 has a cyclicity of 1. So the unit digit is 6. What is a unit digit of 3? This is 253 raised to 121. Nothing but 3 raised to 121. But what is the cyclicity of 3? 4. So I'll divide this by 4. If I divide this by 4, what's the remainder? 1. Which means this is similar to 3 raised to 1. 3 raised to 1 ends in a 3. So unit digit for this is 3. Okay, similarly, this is nothing but 7 raised to 782. I am asking you what is the unit digit of this. Okay, so you will say, okay, 7 raised to 782. What is the cyclicity of 7? 4. So divide this by 4. 82 raised to 4. The remainder is 2. So this is similar to 7 square. 7 square is a unit digit of 9. So this is a unit digit of 9. Let's multiply 16 into 3, 18 into 9. 8 9s are 72. I just want the unit digit. So the unit digit is 2. Okay, so what do? I find the unit digit of first this, I find the unit digit of this, I find the unit digit of this. In the end, I multiply the unit digit to get the final unit digit for my entire expression. Okay, so I think this clears the concept with relate to unit digit. How do you find out last 2 digits now? Okay, that is where all the students find a concern. So first we'll see a method. In the next 5 minutes we'll finish this as well. So first we'll see a method to find out the last 2 digits of numbers ending in 1. Okay, please remember this. This is only a shortcut to find out the last 2 digits of numbers ending in 1. What is the shortcut? Say I need to find out the last 2 digits of 81 raised to 121. What is the unit digit? Obviously we know it has to be 1, right? It has to be 1 because 1 cyclicity is 1. How do you find out the 10th digit? Just multiply this last 1 by the second last of this. 1 into 8 is what? 8. That is my second last digit. In short, any numbers that is ending in 1, how to find out the last 2 digits? Last digit will always be 1. If you can see, The number is big, okay, this number is big, but the unit digit is 1, so the unit digit is 1. How do you find out tens digit? Just multiply this, n into x, n into x. N into x is what? Then this is my tens digit. Okay, so that is how you find out the unit digit. Let me give you an example. 121 raised to 63. What are the last two digits of this? Since this is 1, this is 1. Last digit will be 3 into 2, which is what? 6. 61 will be the last two digit of this number. But you can apply this trick only for the numbers ending in 1. Okay, for the numbers not ending in 1, there is a different method. So let's start. I am asking you now few questions on this. Okay, so 9 raised to 820. What are the last two digits of this? I don't know how to find this out, but I know how to find the last two digits of the numbers ending in 1. So how can I make 9 end in 1? I write it as 9 square. 9 square is nothing but 81. Okay, then I write it as, okay, 9 square is 81. 81 raised to what? 410, right? Because 410 into 2 is nothing but 820. So I write it 81 raised to 410. That's it. Problem is solved. If this is 1, this is 1, right? And how do I get tens digit? 0 into it. 0 into it will be 0, 1. So last two digit of this will be 0, 1. And that's how simple it is. Let's take this 3 raised to 720. I need to find out the last two digits of this. I only know the trick for the numbers ending in 1. So I make 3 end in 1. Now which power of 3 gives me 1? 3 power 4. So I write it as 3 raised to 4 into 180. 3 raised to 4 into, because 180 into 4 is 720. Now how do you write 3 raised to 4? 3 square into 3 square raised to 180. Now what is 3 square? 9. 9 into 9 raised to 180, which is nothing but 81 raised to 180. Now my problem is solved. Since this is 1, this will be 1. What will my tens digit? 0 into it. 0, 1 is the last two digits of 3 raised to 720. What if it was 723? Then what will happen? Okay, similarly I'll write 180 into 4, which is 720. This additional 3 cube will remain at this side. It will remain at this side. So what will happen? I'll solve this 3 square raised to 180 into 27. This is nothing but 81 raised to 180 into 27. I know how to find out this 81. So 1 will remain 1. 0 into 8 will be 0, 1 into 27. What is 1 into 27? 27. That's it. Okay, so I know the trick for ending in 1. So I make the numbers end in 1 and then I apply the trick for ending in 1. Okay, so what else can I do with this? Let's take one more. 7 raised to 2008. Okay, what are the last two digits of this? Now which power of 7 will give me 1? I know 7 power 4. Okay, so remember this, 9 power 2 gives me 1, 3 power 4 gives me 1 and 7 power 4 gives me 1 as well. So I write this as 7 raised to 4. So what is left here? 502, because 502 into 4 is nothing but 2008. Now I write it as 7 square into 7 square raised to 502. What is 7 square? 49. What is 7 square? 49. 49 into 49 raised to 502. Now there are two ways to solve it. Okay, I can find out what is 49 into 49 square, right? What is 49 square? What is 49 square? If you know how to find it out, minus 1, base method. 48, 1 into 1 is 0, 1. Divide this by 2. Answer is 2401. So what this turns out to be? 2401. Just ignore this step. This turns out to be what now? 2401. Okay, this turns out to be my 2401, which is my 49 square raised to 502. Okay, now I know how to solve this. This is 1, this will remain as 1. 2 into 0. Okay, it will remain out to be 0 and then 1. That's it. That will be my last two digits for 7 raised to 2008. Let's try one more. 33 raised to 128. What are the last two digits for this? So what will I do? 3. 3 power what gives me 1? 3 powers 4. So I write it as 4 into 21. Okay, so I write it as what? Now just divide this by 4. 4 3s are 12. 4 2s are 8. Okay, so this will not be 20. This will be my 32. Okay, because this is 128. So I want the 3 power 4. So 4 3s are 12. 4 2s are 2. Now this again everything will change here because the problem was different. We'll make it a different problem here. Okay, so I write this as what now? This is 32. This is also my 32. Okay, and we'll try and solve this now. So let's take it now. What can I do with this? I will write this as 33 square into 33 square. Yes, 33 square raised to 32. Okay, 33 square. 33 square, if you know, is a 4-digit number. But I am telling I don't want the first two digits. I don't want the first two digits. What will be the last two digit of this? Now this is the trick. See if you can get this. You can reduce a lot of time. I'll write this as minus 17 if I am solving by base method. What is 17 square? 89, which means my last two digits will be 89. Which again means my last two digit of this will be 89. If I need the last two digit of some number, let me give an example. 123 into 123. I am telling you I don't want the 3-digit number. I just want the last two of this. So you will say, okay, just multiply 23 into 23 and you will get the last two of this. So I don't want this entire number, this 4-digit number into 4-digit number. I don't want this. I just want the last two of this, so I'll multiply only 89 into 89. Okay, what is 89 into 89, which is nothing but 89 to 89 like this, right? If I have to solve by base method, I'll write minus 11 minus 11. What is 11 square? 121, which means my last two digits will be 21, and this will be 21 raised to 32 now. Okay, so if you can understand, I'm just reducing my time because I'm only taking the last 2 here, because that is what is being required. Okay, now 21, now problem is solved. This is 1, so which is 1, 2 into 2 is 4, 41 is my answer to this. Okay, so just remember the basics related to it. Let's take one more. This should clear all your problem. 37 raised to 64, what are the last two digits of this number? Okay, so let's start with this. So 37 raised to 64. Okay, so what will I do now? I need up 7 power 4 to get a 1 here, so I'll write 4 into 16. 37 raised to 4, so I'll write 37 square into 37 square raised to 16. 37 square, yes, I don't need the 4 digit number, so I don't need the first two digits, right? So I'll say last two digit. 37 square, what will I write? This is, you have to imagine, so minus 13 minus 13. What is 13 square? 69, so last two digits will be 69. Here also last two will be 69. Now I'm left with 69 into 69 to get the last two of this number. Okay, I just need last two. What is 69 square? If I'm solving by base method, I'll write plus 19 plus 19. What is 19 square? 361. It means the last two will be 61. So this remains to be 61 raised to 16. Now this is solved. This is 1, this is 1. This is what? 6 into 6, 36. So my answer for this is 61. Okay, I hope you got the concept for this. Base method is how I am using this. Endeavor class student will be able to again relate to this, because this is how we have solved all the problem related to the last two digits. Okay, so just make sure you are going through these problems as well. The only thing now remains here is, you have told us how to find out the last two digits of numbers who are ending in 1. But what about the numbers who are not ending in 1? Okay, now how do I find out the last two digits of that? Now which are those numbers? 2, yes. 4, yes. 6, yes. 8. None of the 2, 4, 6, 8 will end in your 1. And if it cannot end in 1, I cannot apply the trick of ending in 1. So what is the method to find out the last two of numbers who are not ending in 1? So first thing you have to remember for this is 2 raised to 20 is this big number. All that you have to remember is last two digits of 2 raised to 20 is 76. And what you have to remember, one more thing here is 76 raised to anything, the last two digit is 76. For example, 76 raised to 1, 76. Do a 76 square, the last two digits will be 76. Do a 76 cube, the last two digits will be 76. So 76 raised to anything, the last two digits will always be what? 76. So remember these two things. 2 raised to 20, last two are 76. 76 raised to anything, last two will always be 76. Okay, so I start with this now. I take this number. 2 raised to 105, I need to find out the last two digits of this. What do I know? I know 2 raised to 20. So I write it in terms of this. 2 raised to 20 raised to 5. 20 into 5 is what? 100. I'm left with 2 raised to 5, which is extra here, okay, because it's 105. 2 raised to 20, last two digits are 76. So I write it 76 raised to 5 into 2 raised to 5 is 32. 76 raised to anything, last two digits are always 76. If you can see, again I am comparing only the last two, because last two into last two will give me the last two of the resultant number. So 76 into 32, last two are 32. That's it. You can just multiply this. You also have this trick, okay? 76 multiply by any power of 2. Say it is 2 raised to 5. The last two will always be 32. 76 into 64. The last two will always be 64. Okay, 76 say into 16. Any power of 2, okay? Any power of 2. This 2 to the power 4, to the power 5, to the power 6. Will always be last to be 16. That's it. I know the last two for this is 32. Okay, similarly say I am given 4 raised to 80. Find out the last two of this. So I'll bring it in terms of 2. 2 raised to 80. So 2 raised to 80, which is nothing but 2 raised to 160. What do I know now? 2 raised to 20. So I write it as 2 raised to 20 raised to 8. 2 raised to 20. What are the last two digits? 76. 76 raised to 8 is left now. 76 raised to anything, last two digits is always 76. That's it. So the answer for this is 76. As simple as that. Okay, let's go to this now. 6 raised to 80. Yes, this is where there is a catch in. Okay, what is 6 raised to 80? I can write it as 2 raised to 80 into 3 raised to 80. 2 raised to 80, there is a different method. 3 raised to 80 to solve, there is a different method. So let's solve 2 raised to 80. 2 raised to 20 raised to 4. 2 raised to 20, last two digits 76. 76 raised to 4 is left. 3 raised to, I'll write it as 4 into 20. Why? Because now I'll solve by the method of ending in 1. So 3 raised to 4 is what? 81. This is 81 raised to 20. Okay, now how do I know this? So 1 is 1, it will come here. 0 into 8 will be what? 0, 1. 76 raised to anything will be what? 76. So last two of this is 76. Last two of this is 0, 1. 76 into 1, the answer for this is 76. Okay, so whenever it comes to last two digits, don't be confused. It is the easiest thing that you can get here. So for the numbers ending in 1, we have a trick. For the numbers which are not ending in 1, we make them end in 2 raised to, we find out it by 2 raised to 20 trick, okay, and 76 raised to anything. So just this, remember these two things and you will remember about the last two digits of any number raised to any number. Okay, so this is how where I complete my lab 2 related to factors and factorials. If you guys have any doubts, you can throw it up to me. Okay, I'll be waiting to see any doubts in the next 2 minutes, and in the 2 minutes we'll start up with our lab 3 of LCM and HCF. Okay guys, so let's start with the lab 3. There are not many questions related in the lab 2. Okay, so let's start with the lab 3, which is on LCM and HCF. Okay, so what is LCM? Okay, least common multiple. But first of all, what is a multiple? Okay, what is a multiple to me? Okay, what are the multiples of 5, 10, 15, 20, 25, 30 and then 35? What are the multiples of 10, 10, 20, 30, 40, 50, 60? What are the multiples of 15, 15, 30, 45, 60, 75, 90? Now I'm asking you, what is a common multiple in them? What is a common multiple in them? You can see it's 30. Okay, next common would be 60 and then so on. Now I'm asking you, what is the least common multiple? A multiple which is common to all three of them and least. You will say that is what? 30. Okay, so that is my least common multiple of 5, 10 and 50, which is nothing but 30. So now if I ask you, how do you find out this? Not by doing in this way. Start with the biggest number, which is my 15, and see the multiples of 15, check if they are coming in the table of 5 and 10. Okay, 15 ones are 15, not in the table of 10. 15 twos are 30, it comes in the table of 10, it comes in the table of 5 as well. So 30 is my LCM, least common multiple. So that's how you can find out LCM for simple numbers. Now there is again two ways to find out LCM of any number that is given to you. One is a traditional method, which is say 36, 42 and 56 are given. Just find it out. 2 18s are 36, 2 21s are 42, 2 28 are 56. 2 9 are 18, 2 14 are 28, then you are left with this. 3 3s are 9, 3 7s are 20 and 14 remains here. 3 1s are 3 is remain here, 7 1s are 7, okay, 7 2s are 14. Then in the end you are left with 1 1 1. You do this factorization till the time you are left with 1 1 1. Now just all multiply. 2 into 2 into 3 into 3 into 7 into 2. So what comes out to be answer as 504. So this is one traditional method that you can observe on your LCM. Okay, how to find out least common multiple of three numbers by traditional method. The next method is called as prime factorization. Okay, now what is that? I write this number in terms of prime numbers. Okay, so how can I write 36 in terms of prime numbers? I can write it as 9 4s are 36. Okay, or 3 square into 2 square. I can write 42 as 2 into 3 into 7, 6 7s are 42. I can write 56 at 7 8s are 56, but 8 I can write it as 2 cube. Okay, so I wrote each of the numbers in terms of prime number and I took their powers. Now what am I supposed to do? Write all the distinct number that you can see. I can see a 2, I can see a 3, I can see a 7. What is the highest power of 2 that you can see in all of them? 2, 1, 3. So highest power is 3. What is the highest power of 2 that you can see here? What is the highest power of 3 that you can see in this? Nothing but 2. So I'll write a 2 here. What is the highest power of 7 that you can see in them? Is 1. So that's it. It's 8 into 9 into 7, which is nothing but 72 into 7, which is nothing but 504. Okay, so that is my LCM for this. So this one method of prime factorization by which you can find the LCM. Okay, what is HCF now? what is HCF? So what are factors? We have done a comprehensive class on what are factors. Okay, so what are factors of 10? 1, 2, 5, 10. What are factors of 15? This. What are the factors of 5? You will say 1 and then 5. What is HCF? Highest common factor. Okay, it's a factor which is common in this, which is highest. Factor which is common in this is also 1, right? But I am not asking you least, I am asking you your highest common factor, which is what my 5. So that's my highest common factor. Now how do you find out HCF for 3 bigger numbers? Okay, so the same method goes like prime factorization. I write 288 in terms of prime numbers, which is 2 raised to 5 into 3 square. Okay, I just split it up and get it in this way. I write 432 in terms of prime number, which is again 2 cube into 3 raised to 4. I write 768 by solving it by factorization and writing it in terms of prime number as 2 raised to 8 into 3. Then what do? I write the distinct number here, or you can say one more method is see the common. Okay, what is one thing which is, okay, I'm finding HCF. Okay, so just rub this, yeah. So I need to find out, say, both from this. I need to find out LCM as well as HCF. So LCM we already know. I'll first find out LCM for this. So how do I find out LCM? Write the numbers, distinct number that you can see. I can see a 2, I can see a 3 here. Then what is the highest power of 2 that you can see? It's 8 here. So I'll write an 8 here. What is the highest power of 3 that you can see? That is nothing but 4. That is my LCM. How do I find out HCF from this highest common factor? Again, see the distinct number that you can see, 2 and then 3. In LCM, least you take the highest power, right? In HCF, highest you take the least power. So what is the least power of 2 in all of them? It is nothing but 3. It is nothing but 3. What is the least power of 3 in all of them? This is nothing but my, just check it, 3 least power is 1. Okay, and my least power of 2 here is this. So 8 into 3, this is nothing but 8. 8 into 3 is nothing but my 24. Okay, so let me just check it. What is the least power of 3 here? This is 2 raised to 3, right? So that's how you can find out the HCF for them. Okay, so how do you find out HCF? Just write out the numbers in terms of prime numbers, write out all the distinct number. In LCM you are supposed to see the highest power, and in HCF you are supposed to see the least power. Okay, you're supposed to see the least power. Okay, so I saw the least power of 3 has to be 1, and I saw the least power of my, okay, 2 has to be what? 3. Okay, so let me just check this. This is 216 into 2, so this is 2 into 3 raised to 3 into 3, right? So 2 raised to 3, that's it. That's my HCF for this. Okay, so just know prime factorization as a method to find out HCF as well. How do you find out LCM and HCF of fraction? So this is again one method. Right, 1.8 as 18 by 10, 2 by 1, 24 by 10. I need to find out LCM of this 3, right? Now, I was supposed to find this. Now, I'm supposed to find the LCM of this 3. So, LCM of fraction, you have to remember the formula. It's LCM of fraction upon HCF of, numerator upon HCF of denominator. So, if I were to find out the LCM of fraction, what will it be? What will it be? LCM of fraction, it will be, I think there is some glitch here. Just give me a second, guys. I think there is some glitch here. क्या हुआ? Shit. बोल रहा है unable to connect. हाँ, हो गया. Yes, yes, guys, we are back to it now. So I was on finding out the LCM and HCF of fraction. So if I ask you what is the LCM of this fraction, which is 18 by 10, 2 by 1, 24 by 10. So what will you do? First find out LCM of numerator, and then you find out HCF of the denominator. Okay, so LCM में You have LCM of numerator upon HCF of denominator. Then what will I find out? LCM of numerator. What is the LCM of 18, 2 and 24? Which is what? 72. So I get it here, 72. What is HCF? Highest common factor of 10, 1 and 10, which is 1. So my answer for this is 72. So LCM of this three numbers fraction is nothing but 72. If I ask you HCF, so the formula will change as HCF of numerator upon LCM of denominator. Okay. So what is the highest common factor of 18, 2 and 24? Which is 2. What is the LCM of 10, 1 and 2? Least common multiple is 10. So 2 divided by 10. Answer is 0.2. Okay, so just remember this one thing again as a warm up of LCM and HCF. If you ask an fraction LCM, it is LCM of numerator upon HCF of denominator. If you ask an fraction HCF, it is HCF of numerator upon LCM of denominator. Okay, so this should clear your concept. Now we come on to main application of LCM HCF. Okay, so all that you have to remember now is this properties. Okay, so product of two numbers is LCM into HCF. Okay, so let's take two numbers, say 5 and then 10. Okay, product of two numbers 5 into 10 is 50 is equals to LCM of two numbers. What is LCM of them? Least common multiple of them is what? 10. Right? Least common multiple of 5 and 10. And what is the highest common factor? It is nothing but 5. Okay, highest common factor of 5 and then 10 will be 5. So LCM of two numbers 10 into HCF, 10 into 5 will always be equal to 50. This is true for any of the two numbers that you pick up. So LCM of numbers into HCF of numbers will always give me what? The product of numbers. Two numbers. Okay. So let's start with the property understanding this better. I am saying HCF of two numbers is X. Okay. So I am saying the HCF of two numbers is X, which is nothing but my 5 here as per my example. I can write now one number as X into A. I can write one number as 5 into 1, which is nothing but my 5. Okay, I can write other number as 5 into 2, which is nothing but my 10. 5 into 2, which is nothing but my 10. Such that A and B, what is A and B right now? 1 and 2 will always be what? Co-prime to each other. Okay, and we had already learned what is co-prime. The HCF, highest common factor for them will be what? 1. Okay, so this is the property. If the HCF of two number is X, I can write one number as X into A. I can write other number as X into B such that A and B are always co-prime to each other. Okay, the first thing that you have to remember. And now the LCM of this two number is given by the thing X into A into B. So let's take an example. What is my X as per my example? 5. What is my A as per my example? It is 1. What is my B as per my example? It is 2. So 5 into 1 into 2, which is nothing but my LCM. Check it. The LCM is what? 10. Okay, so just remember HCF of two number X, one number XA, other number XB, A and B are co-prime. LCM is given by XAB. So let's apply this property. LCM of two number is given to be 196. HCF of two numbers is 7. So I can say, okay, if HCF is 7, I can write one number as 7 into A, other number as 7 into B. LCM is 7 into A into B. Okay, we are just applying this property XA, XB, XAB. So we are just applying this property 7A into 7B, 7AB is equal to 8. So A into B is 28. So how can I write A and B as a product of two numbers? I can write 1 into 128, yes. I can write 2 into 14, 28, yes. I can write 4 into 7 as 28. But what do I know about A and B? They has to be what? Co-prime to each other. They have to be co-prime to each other, which means HCF has to be 1. They are not co-prime. So this is gone. So I am left with this and this case. Now one number is what? 7 into A. Other number is what? 7 into B. So I write it here. 7 into A. A could be 1. B could be 28. Okay. This AB is equal to BA because finally this is 7A and 7B. Both the number will be same. So 1 into 28 is same as 28 into 1, right? So that is not a different case in this. So my one number would be 7 into 1, which is 7. Other number would be 7 into 28, which is 196. But the question is saying one more thing. If the difference of the two number is 21, difference is 28. In this case, the difference is not 21, right? So this case is also gone. Now 4. So if I put A as 4, one number is 7 into 4, 28. Other number is 7 into 7, 49. Difference between them is what? 21. He is asking me what are the two numbers. Now I know what are the two numbers. It is 28 and 49, such that the difference between them is 21. Okay. So just have an idea how to use such properties to reach to an answer. Again, this is one more problem. HCF of two numbers is 6. Product of two numbers is 4320. How many such pairs of numbers exist? Okay. So he is asking me how many such pairs of numbers exist. So if HCF is 6, one number could be written as 6 into A, other number could be written as 6 into B, But I know the product of two numbers, which means 6a into 6b is nothing but 4320. So I know what? A into b is equals to 4320 divided by 36. So a into b is equals to what now? 120. Now I need the multiplication of a into b to be 120. So how can I write 1 into 120? Yes. 2 into 60, 3 into 40, nothing but factors of 120. Okay. 5 into 24, 6 into 20, 8 into 15, 10 into 12. But what is the condition with a and b? A and b has to be what? A and b has to be co-prime to each other, not 1. So what are co-prime? This is a co-prime, this is a co-prime, this is a co-prime, and this is a co-prime. So how many pairs? Because I'm just following the property. Okay, it's 3. So I'm saying one number is 3a, other number is 3b. Yeah. And if the HCF of any two of the three numbers is nothing but 3, will be equal to what? 1620. What is he asking me? What is their LCM? Yes, as we have just learned, LCM of this three number would be 3ABC, right? We know XAB. So now we have 3. So XABC, okay? And ABC will be what? Co-prime to each other. So it is just the only difference here in this problem is instead of 2 numbers, I have 3 numbers here. Okay, so now how will I solve this? I'll take this 9 out. Okay, I take this 9 out because I know 27 ABC is this. I take this 9 out. So what am I left with? 3 ABC is 1620. 3 ABC is equals to 1620 divided by 9, okay, which is nothing but 180. That's it. That is what he was asking me. What is the LCM of this number? And the LCM is nothing but 3 ABC. I don't need to find the answer what is A, what is B, what is C. I need to find the answer for what is 3 ABC. And I know now what is 3 ABC, 180. So LCM of this 3 number is nothing but 180. Okay, so again applying the same properties that we have learned with LCM HCF. One more problem which could be an hurdle problem on LCM HCF. How many pairs of natural numbers both less than 100 are there such that their difference is 49 and HCF is 7? So I say okay, one number is 7a, other number is 7b. Since their difference is 49, 7a minus 7b will be equal to 49. So I know 7 into a minus b will be equal to what? 49. So a minus b will be equal to what? 7. Okay, and I know a and b has to be co-prime. So what are the numbers that I can write? 8, 1, 9, 2, 10, 3, 10 minus 3, 7, 11 minus 4, 12 minus 5 and 13 minus 6. Why can't I go to 14? Because these are, both the numbers are less than 100. Okay, if I put a as 14, 14 into 7 is what? 14 into 7 plus 108. The number will be greater than your 100, and I know both the numbers are less than 100. So the maximum I can go is still 13. So how many? What is he asking? How many pairs of natural numbers both less than 100? How many are there? 1, 2, 3, 4, 5 and then 6. You can form 6 such pairs of natural numbers, both of which will be less than 100, such that their difference will be 49 and their HCF, highest common factor, will be what? 7. Okay, so 6 such pairs are possible. Now these are last few 10 minutes before we are done with this. So let's see, the front wheel, again an application of LCM HCF is a problem because we have not seen a word based problem on this. So let's see one word based problem. The front wheel of a wagon measures 3.5 feet in diameter. This is my front wheel. The rear wheel measures 4.25 feet in diameter. Okay. While the wagon is stopped, somebody makes a chalk mark where the wheel touches the road on the front and the rear wheel. So this wagon is standing and I make a mark. I make a mark here and I make a mark here. Okay. Then what is happening? Makes a mark when the wheel touches the front and the. How far must the wagon travel before both the chalk mark return to their initial position at the same time? Okay, so now this wagon is traveling. When will it happen that this chalk mark will again hit the ground on the same time? Okay, so what is he asking me? When will it happen? So if you can see, this will have what? More revolution, right? Because it is smaller. This will have less revolution. Why? Because it is bigger. When will they hit the ground? Again at the same mark, when they have to cover this distance. When they have to cover this distance, they will hit the ground again at the same time. But what is this distance? This is nothing but circumference 2 pi r. What is this distance in this case? Nothing but again circumference, which is nothing but 2 pi r. Okay, so they have to complete this one distance of revolution. 2 pi r could be written as pi d here. It could be written as pi d here. What is diameter of this? 4.25. What is diameter of this? 3.5. Now I need nothing but LCM of this three. Okay, so to give you an example, one clock vibrates after every 5 seconds, the other vibrates at every 10 seconds. When will they vibrate together? After 10 seconds. So this will vibrate twice, 5 and then 10. This will vibrate only once. After 10 seconds they will vibrate together. Similarly, when will they meet? Okay, which is nothing but LCM of this two. Okay, so what is the LCM of this two? I read it as 425 divided by 100 into pi, 35 by 100. Okay, I solve it as 17, 4, 7 and then 2. Now LCM of fraction, which is LCM of numerator upon HCF of denominator. What is LCM of 17 and 7? 119. HCF of 4 and 2, 2. 119 divided by 2, 59.5. So 59.5 is the answer for this. Okay, that is when both the chalk marks will return to their initial position. So this was one application of LCM as to when will these two things which are happening at a different interval will happen at one interval. Okay, so this should give you an idea of the problem. This is one or two problem on successive remainders which I would like to cover here. So what is given? N is a natural number which is successively divided by 5, 6, 7, 8. The remainders are 1, 2, 3, 4 respectively. What will be the sum of the remainders if the order of division is reversed? Okay, so I am saying you are dividing a number by 5, you are getting a remainder as what? 1. Then you are dividing the same number by 6, you are getting the remainder as 2. Then you are dividing the number by 7, you are getting the remainder as 4. Then you are dividing the number by 8, the quotient is something that will written here and the remainder will be 5. Okay, what will happen if the order of the division is reversed? So I am telling let the last quotient be x. What will this number be now? 8x plus 5. Okay, what is the logic here? So let's come here. If I say 2 divided by 11, 2 5s are 10, right? And the remainder is 1. If I have to get this 11, what will you do? 2 into 5 you will multiply and you will add the remainder. So, okay, so it will be 2 into 5 plus 1 which will give me 11. Similarly, if I need this number, what will I do? I will multiply 8 into x plus 5, this will be 8x plus 5. Okay, if I need this number 7 here, I will multiply 7 into 8, this comes out, the same thing is being solved here. 7 into 8, 56 plus 7 5s are 35 plus 5, it will be 39. 35, 7 5s are 35 plus 4, sorry, this plus 4 will also be there. So this will be now 39. 56 plus 35 plus 4. Similarly, I will multiply this 6 with this and add 2 to it to get this. 6 into 56 will be 336 plus 6 into 39 plus 2 which will give me 236. Similarly, I will multiply this, add 1 to this to get this. Okay, so this is my number 1680x plus 1181. Which is smallest such number? Put x as 0. Put x as 0, so the answer comes out to be 1181. This is my smallest such number. So now what do? I know the smallest such number. Now order of division is reversed. So instead of dividing it first by 5, I divide it by 8. 8, then 7, then 6 and then 5. So first I divide this by 8, the quotient is 147, remainder is 5. I divide it by 7, the quotient is 21, remainder is 0. I divide it by 6, quotient is 3, remainder is 0. If this is 3, then the final remainder is 3. Add all of them, 5, 6, 7, 8, 9, 10, 11. Okay, so the sum of the remainders now will be 11. So this was one problem on successive remainder which should give you an idea about how do you go ahead with such kind of problems. Okay, so these are the things which I wanted you to know about this. Now last problem or of the few would be on just finding out the largest power. Okay, so what am I asking you right now? How to find out the largest 4 or 5 digit number divisible by any particular number. So I am asking you largest 2 digit number divisible by 7. How will you find it out? Write the largest number here. Then find the remainder. 7 ones are 7, 29, 7 fours are 28. What's the remainder? 1. Subtract that 1 from here. Okay, subtract that 1 from here. So just let's check it. 7 ones are 7, 2 9, 7 fours are 28. So what is it? 99 minus 1 will be 98. Okay, is largest 2 digit number which is divisible by 7. Similarly, if I ask you largest 4 digit number divisible by 21, you write a 21 here, you write the largest 4 digit number here, you solve it, 4s are 84, you get the remainder, you keep on solving it, you get the final remainder as 3. Now subtract 9999 minus 3 will be what? 9996. Largest 4 digit number that is divisible by 21. Okay, so that is again one thing that you guys should go through. So this is one table which should give you a comprehensive idea of how do you go ahead with such kind of problem. Now I am asking you first, smallest number divisible by 3, 4, 5, it will be 60. Smallest number divisible by 3, 4, 5 leaving a remainder of 1 in each case. So just add 1 to 60, it will be what? 61, right? Smallest number now divisible by 3, 4, 5, it leaves a remainder of 1, 2 and 3 respectively, yes. So when I divide by 3, it leaves a remainder of 1. When I divide by 4, it leaves a remainder of 2. When I divide by 5, it leaves a remainder of 3. Is there a common thing here? The difference here is 2. The difference here is 2. The difference here is 2. Okay, so what do I do here? First find out the least common multiple of 3, 4, 5, which is what? 60. And subtract the difference that you are getting from this. So 60 minus 2 is 58 by 5. You will get a remainder of 3. Okay, so that is my number. If I ask you second smallest, just take the multiple of this. If I ask you second smallest here, into 2. If I ask you smallest 4-digit number here, you will find 1020. How do you do this now? Just take 1000 here. Just take 1000 here and put a 60 here. The same method which we have done. 60 ones are 60. What are you left with now? 400. 66 are 360. Okay, so what are you left with? 40. If you add 20 more to this, you will get the answer. So this is nothing but 1020. Or you can say 1000 minus 20 is 960. If you add 40 to this, you will get 1020. Okay, so that is my number. Smallest 4-digit number. If I ask you largest 5-digit number divisible by this, so what will you take? Largest 5-digit, so you will take a 60 here, and largest 5-digit 99999. You will solve this, you will get a remainder, subtract from this, and you will get the answer for this as well. Okay, if I asked you now the largest 5-digit number when divided by 3, 4, 5, leaving a remainder of 1 in each case. So first you will find the largest 5-digit number divisible by 3, 4, 5, which is what? 99960. Add 1 to it. Add 1 to it. That will be my answer. Similarly, if I ask you what is the largest 5-digit number divided by 3, 4, 5, leaving a remainder of 1, 2, 3. So first find out largest 5-digit, then subtract 2 from it. Okay? Then subtract 2 from it. So my answer would be 99958. Okay, I hope this gives you a better answer of how to go ahead with such kind of question. Okay, so this would be last one of my problem on this. Largest 5-digit number which is divisible by this. So I find out the LCM of this 5, which comes out to be 10080. Since you are asking me largest 5-digit number, I write it here. I keep a solving here. So I come out remainder to be 9279. Subtract from this, you will get the answer as 90720. This is the largest 5-digit number that is divisible by 32, 36, 40, 42 and 48. Okay, that's it guys. We have come to the end of our triathlon now. So I just want you to go through all the remainder problem, factors, factorials problem. Okay, and this triathlon, just revise it in a way that going through basic problem and coming on to eventually to difficult problems. Okay, I would just like to throw light on certain things. We have our online product. Okay, we have our online product which you can check it on our website. So I'm just letting you know, go through this online product. This is our website and you can check out our CAT courses online product. It's our 15th anniversary. So we had given a lot of scholarship on the product. Now what I taught you right now was just like 5% of the numbers chapter itself, because the number chapter itself in it is so big. Okay, I had not covered base system and so problems related to that. But in this courses, you will find there is a CAT comprehensive course 2019. Because of anniversary offer, it is giving at a half a price on this. Okay, there is a CAT advantage course as well. Then there is a CAT test series here as well. All these courses includes the video lectures which are being required for you guys. Okay, so please make sure going through our website, checking out all these courses, because even these courses include the comprehensive analysis of many of the chapters related to verbal. Now what I had covered is only one chapter from Quant, that is numbers. Quant itself has many chapters, so all these chapters are being given as recorded thing in this product which is given online. So you can check out these products. Not only that, if you feel like you have studied all the concepts related to CAT and you need to join only for the test series, so we have our test series product as well, which is there on our website. You can check this out, CAT Comprehensive Test Series 2019, which has somewhere around 50 plus mocks. Not only that, it has somewhere around 300 plus sectional tests as well. Okay, so you can consider 100 sectional tests for each one of them. Okay, so do check out our website and let us know how do you find this webinar. Okay, this was a great experience interacting with you guys. See you in the next triathlon webinar, which could possibly be on higher algebra. Okay, thanks a lot.